Dear participants, it is an honor for me and the organizing committee of this online FDP to welcome our respected resource person, Professor Dr. T. Ghosh, Professor Electrical and Electronics Engineering Department, Build and Stoke Technology, Mesra, Ranchi, to deliver his lecture on renewable energy integration, technical impacts, IEEE standards, and patent considerations. It is our privilege to introduce Dr. Tirthadeep Ghosh, who is professor in the Department of Electrical and Electronics Engineering at BIT Mesra, Ranchi. Dr. Ghosh holds a PhD in engineering from Jadavpur University and has over 25 years of distinguished experience in teaching, research, and academic leadership in the domain of power systems. His research interests span hybrid AC-DC microgrids, renewable energy integration, battery energy storage systems, demand response, microgrid operation and control, and blockchain applications in power systems. He has successfully guided numerous doctoral scholars and has been the principal investigator for several prestigious research projects funded by AICTE, SERB DST, ERLDC, UGC, and DST FIST. Dr. Ghosh has been instrumental in establishing the Smart Grid Laboratory at BIT Mesra Ranchi, equipped with advanced microgrid test beds, grid forming and grid following inverter systems, and battery performance evaluation platforms. His contributions continue to bridge academic research with practical, industry relevant solutions, particularly in the evolving areas of smart grids and sustainable energy systems. Sir, it is an honor to have you among us. I request you to please start with your session.
Uh, thank you, participants. Thank you, Dr. Acharya, for introducing me with the participants. Can you hear me? Hello, am I audible?
Yes, sir. Yes,
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 sir.
sir.
Fine,
Yes, sir.
thank you.
Yes.
So the scheme is different. I am working on basically in power systems, taking care of renewable integration. That is my focus of research nowadays. I have started with analysis of different types of analysis, starting with my PhD thesis is uh, in 99. I have got the PhD degree with capacitor placement. What are the locations of capacitor placement in distribution systems? And from there, then I started unit commitment. Then I thought that renewable coming in a big ways. So I shift my focus on renewable sources and its integration. I'm trying to understand power electronics behind that. Still, I am learning. It's very difficult to shift those who are working on conventional analysis of power systems. Wanting to shift focus to renewable integrations. Power electronics is not very easy. Still learning. With taking the help of power electronics faculty from my department. But a very interesting topic that basically when electric vehicles are coming in picture in a big way, then it affects the power systems also, power system stability. A little bit I will discuss on that. That is the reason by 2070 Government of India signed a pact that is COP26. Our Prime Minister signed there and promised to reduce the carbon-free country India by 2070. So zero carbon emission, if it is in our emission, our achievement, our goal to be achieved by 2070 is not very easy task. So there are two factors actually which are polluting mostly our environment, which are introducing greenhouse gases to our environment. These are the two regions are basically the fossil fuel based power plant. Number one, they are the culprit. Number one culprit is fossil fuel based power plant where we are burning coals, and for burning coals, greenhouse gases are generated. Number two culprits are the your petroleum run vehicles, right? Petroleum dependent vehicles, they are the second culprit for polluting this environment. And that's why the topic of this FDP is very, very important. So if we want to remove the first two culprits, mostly the electrical engineers helps are required, because you have to shift your focus from fossil fuel based power plant to renewable sources power plant, which are basically environment free power generating plants, that is the renewable energy power plants. Who will do that? Again, the electrical engineers. And if you want to replace the petroleum run electric vehicles by EV, then again electrical engineers coming in picture. So their jobs, that's why I always say that a bright future ahead of our electrical and electronics engineering students. Now, little bit I want to discuss, though something you know, but still why it is not moving. 1 minute, just. So that is the electricity grid. Uh, I have intentionally deleted cross the existing word, because that type of electricity grid, which we usually give a reference in the classroom teaching, basically this is not existing nowadays, right? That's why intentionally I cross this existing word. That is the electricity grid, older electricity grid that is not existing nowadays. Though we are referring this one in our class in basic power system classes. So where you see the conventional plants in the upstream and loads are in the downstreams, there are long transmission lines between these two. And then these are the culprits I have told, that power generating stations which are heavily depending on burning fuels, generating carbon monoxide, nitrous oxide, nitric oxide, carbon dioxide, right? And large transmission line dependency actually makes the systems less reliable. If a line is outage from generating stations, a long transmission lines, you see that our Farakka in our region is one of the biggest largest generating units in Farakka in West Bengal. Power is, we are Jharkhand people is getting power, Odisha is getting power from the generation generated by Farakka thermal power plant unit under NTPC, right? So it's a long transmission line, right? Farakka power we are getting in Jharkhand via Bihar. It's a more than 200 kilometer, right? That 200-kilometer transmission line, while it is traveling, if any transmission line is outage, there is a big reason, sir, that why we know we describe that one, that that is exposed to the nature, and and due to lightning, that is the main cause. A line to ground fall, three-phase to ground fall happens at the pole end, and then it creates a temporary outage from the that power transmission from generating stations to load, right? A line is outage, you see 200 kilometer, and that huge amount of customers will not get power till that problem is removed, right? All faults are not a temporary lack of faults, right? Now you see that these are the carbon monoxide depending on generating stations, long transmission lines. That long transmission lines causes the transmission line losses, right? And now not a resource, is nowadays not existing. We are taking the help of renewable sources and connecting. The renewable sources are free from pollution, environment pollution creation, right? So that's why this type of solar and wind, this type of biofuel, uh, this type of biofuel type of generating station, a small generating station, easily we can connect in the distribution systems, and we can make less dependency systems which are mostly depending on the thermal power plant, right? So if you want to achieve that carbon free environment, right? Then zero carbon emission policy, if we have adopted, if we can achieve that one, obviously we have to achieve zero generation from the thermal generating stations. Zero generation from the thermal generating station means, in other sense, that 100% dependency on the renewable sources, right? 100% dependency on electric vehicle, right? So these two culprits, if we can remove from my system, then we can achieve that one. And but it's a lot of challenges ahead, right? Lot of challenges. Not easy to say, but implementation as a power system engineer, we understand that one. Something we'll discuss. Something what are the alternative solutions I am thinking. My group is working on that. That also I'll try to highlight at the end of my lecture if I get time. Now you see that one. Now, if I move that one from there, so before starting my original thinking on that particular issues, I want to show one slide that where 2012, 30th June and 30th July and 31st July, what happened in India. So in India, that is in 2012 blackout is the largest blackout in world, right? 600 million people are affected for 2 days, right? So what is happening? Very peculiar things happens. Why we are shifting our focus to renewables? Not only the pollution, that type of problems we want to remove from my system. So what happens on this particular day in 2012? That is a Bina Gwalior line. That line is connected, and that line is a 400 kV double circuit line, and which is actually tie lines between western zone and one of the tie lines between western zone and the northern zone, right? And that in the month of July, that day, on that particular day, it's a rainy day in the northern zone, but in the western zone it is a hot day, right? Humid day, I want to say. So it's a rainy day in the western zone and very humid day on the northern zone, right? Rainy day in the western zone and very humid day on the northern zone. And western zone, rainy day, though they have less requirement of power in their own zone, but northern zone they have a huge demand on that particular day, right? So that for one of the 400 kV line out of this double circuit line, which are connected Bina and Gwalior, connecting two zones. Well, that one line was gone for the maintenance. That only one circuit is alive on that particular day, and the huge amount happens drawing from for by the northern zone through this line. Actually, the impedance relay comes in picture, right? We know the characteristics, conditions for impedance relay. Then if the V by I is coming under this circle radius, then it will trip. So at high amount of current through this single circuit line, and that and voltage of the northern zone was not so high, is less basically because there is lot of reactive power demand, because humid day all ACs, all fans are switch on, and that's why voltage is very less at the northern zone because of huge amount of active and reactive power requirement, and current was very high, and that V by I ratio comes within this radius of the impedance relays, and then this impedance relay trip, still there was no fault. The relay is tripped because of no fault, because of this V by I abnormally high, that ratio comes the the fixed desired value of that. So if it is come within this radius of circle, then that trips, and if this line is tripped, huge amount of power is flowing through this single circuit line. If I remember correctly, it is a 500 megawatt power is flowing through this single circuit line. That 500 megawatt which is not flown, it is tripped to the eastern zone. So all the eastern zone is connected. A western zone, you see that if you can arrow, if you can follow my arrow, then it is also through this route. Western zone is connected to eastern zone, and eastern zone again is connected to the northern zone. So the power which is not flowing through this 500 megawatt power is which is not flowing through this line because of malfunction of this. We say usually malfunction of this particular trip. There is no fault. Still that impedance relay trips this particular line. The huge amount of power is flowing through the western zone to eastern zone. That then when eastern zones generating stations feels huge amount of delta deviation, we know the delta stability, right? So delta deviations, huge amount of delta deviations, because load 500 megawatt load suddenly comes on these generators which are in line with in eastern zone. That delta deviation causes several tripping happens in the line as well as the generators which are connected in the grid, eastern grid and the northern grid. And then this tripping causes the eastern regions peoples under dark, and that northern zones, then there is a less amount of power available in eastern zone. Western zone, because there is no such lines left to evacuate huge amount of power which was surplus power in the western zone, because that day in western zone was a rainy day. So they are not getting any lines left to evacuate that power. So no use of that power of surplus power of in western zone. Then but eastern zones line stripping happens, generating unit stripping happens. Northern zones powers are now very less. Demand is very high. Then there is under voltage relays in the northern zone starts stripping. Under frequency relay starts stripping. Northern zone almost goes to blackout. Eastern zone almost 2/3 people. Southern zone left. Western zone also affected because some of the tie lines, some of the interstate lines are tripped, and then because having a surplus, lot of surplus power left suddenly in the western zone, but the southern zone is saved on this particular day. I am talking about the 2012. That time new grid was existing, but not new grid means I want to say northern, eastern, western. That new grid as along with the eastern zone, northeastern zone. This new grid was there, but southern zone is connected with the western zone by HVDC line, right, on a asynchronous mode. They are not synchronized. On that 2014, I think we have achieved one country, one nation, one frequency, because yeah, the southern zone is connected with the eastern zone by AC link. Anyway, so that is the problem. The problem, why I want to describe that slide, because of that if you depend on highly depending on transmission lines, high voltage transmission lines carrying huge amount of power, then if this line is stripped, this is one of the reasons, then other cascading effects tripping the other existing lines in the zone, out of the zones, and whole country is affected, right? Because a tripping 400 kV line tripping 500 megawatt suddenly drops, going trying to, because it's a loop network. It's a loop network. Transmission lines basically a loop network. Distribution lines are radial network, but transmission networks are loop network. So that existing line will be heavily affected, right? it can be eliminated if we depending on smaller units connected in the distribution systems, right? So now we move to the next slide. So our systems nowadays like that, right? So that's why it is an existing system, or that system was not now following, right? So your transmission, you see, if you follow my cursor, you see that one, the wind and the solar are connected, a huge wind plant and solar plant generating 500 megawatt, right? So that type of generating plant, if you these are in the systems, they are connected in the high voltage network. But a smaller unit, if you see, these are connected in the distribution network. So you know that if you want to evacuate that basic equation, electrical engineers, those who are present here, I think almost all of them, we know the equations are power flowing from one grid to another grid is V1. If I neglect the resistance, so it is a V1, V2 by X sine delta 1 minus delta 2. So if you want to send huge amount of power, so your voltage V1 voltage should be very, very high, right? That's why a huge amount, that is the explanation, that is the huge power plant. If you want to integrate with the systems, so you have to depend on the integration voltage will be very high. If you want to integrate a smaller unit of the source, then obviously you can go for 11 kV or 415 voltage, right? So this equation is again V1 minus V2. Sorry, V1 into V2 by X sine delta 1 minus delta 2. V1 into V2, not minus. V1 into V2 by X sine delta 1 minus delta 2. So less amount of power if you want to send from 1 to 2, then the voltage values, if it is less, that is sufficient, right? So if we use the smaller unit, then your distribution network becomes a microgrid, right? That is another one topic, right? Microgrid, and microgrid is a solution, because my personal view is that if you want to achieve zero carbon emission, then there is only one solution, is the microgrid, right? That microgrid, if it is a self-sufficient microgrids, all the microgrids, if you are self-sufficient, which can meet its own load, then you need not to depend on your high voltage transmission lines or this type of fossil fuel power based plant, right? So, so what is the picture? That is a picture, is a very important picture. You see, Government of India is working, right? They are making green corridors, because you see, in the thing is changing. A very remarkable shift is happening, right? You see the before coming to these renewable sources dominating in our power generation mix, that time southern zone was the having the deficit generation, right? The eastern zones are helping, right? Talcher Kolar line, if you remember, I think there is a second largest SBDC link, second or third largest SBDC link nowadays. Huge amount of power is going from the Orissa to Kolar. Kolar is near to Bangalore, right? So, so now, because we are helping them at that time, but nowadays it is a different scenario, right? Sea coast are generating lot of wind powers. Rajasthans are generating lot of, Tamil Nadu, Rajasthans are generating lot of solar powers, as well as the your coastal areas are generating lot of wind powers. They are now having surplus generation, right? That is a issue. Then how to evacuate? Government of India thinking that green corridors, let's try to establish green corridors, means the renewable powers which are generating in the southern zone of the country will send to the other zones through the lines which are dedicated for the renewable sources, right? It's a very big issue. It's a stability issue. Lot of works happening, that a single line is evacuating solar power, wind power, thermal power, and they are having a different characteristics of generation, different characteristics behavior when voltage and frequency changes. then stability is a very big issue. So they are thinking that a separate dedicated line, let's starting from the southern zone. Obviously, they are having a surplus power, and then that to be extended to our areas, right? So now you see, it's an interesting picture, right? I have downloaded it from the Ministry of Power, right, last night for this presentation. And I am also very happy to see the figure. 49%, 49.7% are actually generating from the, it is a 2025, somewhere it is written, right? 31st July, wherever it is written, somewhere it is written. That is very latest data available in Ministry of Power. 49% or 50%, almost 50-50 sharing happening between fossil fuel and non-fossil fuel. Very good achievement, right? By 2070, some of you will be, we can see, I will not see. Right, by 2070, these green colors will be 100%, right? That is the achievement. If we can achieve no carbon emission from the generating sector, right? Very good achievement, and hopefully we will achieve that one by 2070. Now technical challenges, right? All the things are very good, listening to that. But the technical challenges, synchronous generators are very good. If you want to see, if you remove this this problem, that is a greenhouse gas emission, if you remove that one, otherwise it is a very good unit in terms of, if you see that controller, right? So there is a exciter controller, different exciter controller, which actually taking care of voltage. There is another one separate governor controller, which will take care of frequency, decouple two controllers, very easy to control, right? Does not involving any switches like inverter control, right? Lot of problems in switch latching problem solution, right? Same inverter carrying voltage as well as the taking care of voltage control and frequency control. Very difficult to decouple. We are using DQ. Uh, that's why a synchronous generator is easier to control, right? Because another thing is that why it is easier to control, because synchronous generators having a large inertia, and then if any disturbance comes in the grid, then the kinetic energy stored in the rotating mass can support you few seconds after the disturbance. In this few seconds is very important, because you see that few seconds is gives a life to the controllers, because controller requires some time. It will sense the disturbance. It will uh, change the steam turbine, sorry, a valve control, right? Controlling a valve having a mass also. So that valve opening the or closing more or opening more, whatever happening depending on the voltage and frequency, that then steam goes to the turbine through a long pipe. So that type of time required, that time is managed. Yeah, the kinetic energy stored in the rotating mass, it releases and trying to support the extra active and reactive power required in the grid. And by this time, controller starts taking action and completes the action, changes the valve position, and sends the more steam to turbine. So this is not actually existing when you are depending on fuel cell, depending on solar cell, right? Wind generator having a synchronous generator, that is a separate issue, but that problem having a different problem, right? Well, you need to know that what is the wind velocity at that time. If you want to extract more power from the wind velocity, wind turbine may not support you at that time, because it is already generating extra power. It is not happening with synchronous generator. If you have a boiler having a sufficient volume, if you inject coal to the boiler generates steam, right? if you have sufficient coal at your hand and good quality coal at your hand, right? It's a very easy, but your intermittency of source, that time when you need more power from the wind or from the solar, and solar irradiance and wind velocity does not support, it is already generating maximum power. From that you cannot get, right? You cannot get the more than maximum power, MPPT power from the solar and wind. That is the issue. So fall right through is better. We'll see that one. That is the challenges. I have done one work. I have given that work in the, I think so, in the reference. You see that that this intermittency of the wind generator, that work I did with my PhD student. That what he did, that wind turbine, wind velocity. We have taken 3 years historical data. I will stop, Deep Shekhar, when you when you tell me to stop. Okay. So when wind now question is that wind velocity intermittency we are trying to understand by taking the historical data. It is available, and then you see that there is a common DC link here. The two DC points, link point, which are connected battery in parallel with the wind, and there is a DC link capacitor. 1 minute.
Hello, good afternoon, sir. Hello, sir. Am I audible, sir?
Yes, you are audible.
Sir, I think the slides are not visible.
Let's see. Audio.
Hello.
Yes, yes,
Hello,
yes.
good afternoon, sir.
Yes,
Sir,
one
I
minute.
think there was some interruption, sir.
Okay, okay, okay. I am again starting from this.
Sure, sir. Sure, sir.
So can you hear me? Hello?
Yes, sir.
Yes, sir. You are audible
Yes,
and your
fine,
screen
fine.
is also visible, sir.
Okay. So I think that I have covered. So that from that one is covered, right? That one is
Yes, sir.
covered, and
Yes, sir. This
yes,
slide is
fine.
covered, sir.
So now you see that. So what we have done here, that we want to see the size of the battery, one size of battery taking care of two things, right? That because you see, if you are depending on solar and wind heavily, then in power systems, pre-commitment is very much essential, right? If voltage and frequency changes, if you want to see that you want to support that voltage and frequency instantaneously, right? And huge amount of power cannot be stored. That is a big issue in the power systems, right? Big issue, right? So huge amount of power you cannot store. Then if voltage and frequency changes, and that to be meet instantaneously, otherwise tie lines are that day what happens, tie lines are broken, then pre-commitment is essential. Because of that, huge amount of power cannot be stored. When the problem comes, then it will be made instantaneously, it is not happen in power systems, right? People are working on capacitors, power capacitors, but it is not economical. So now question is that then pre-commitment is required. So wind and solar, government of India also having rules related to that, that you have to commit power, that how much power, even it is a renewable sources, God dependent, solar irradiance and wind velocity, not God dependent. It's a science behind. Now you see that still you have to commit 24 hours before that, tomorrow at every 15 minutes how much power to be generated. Day starts from 12 night. Right. If it is that situation, you have to commit the power. If you cannot meet the committed power at the on the particular day, on the particular day, then on the on the particular on the particular day, then you will be penalized, right? Government of India is telling, I think it is a 1 hour time they have given. If you are deviating, you are generating power from the committed power because of renewable sources. But after 1 hour, that time I have forgotten, but you check it. It is there in the. So if power is deviating from your committed power after half an hour or 1 hour, is still deviation happening, then heavy penalty will be imposed on you. Even your generating stations are depending on renewable sources. Now, now you cannot say at that time, after half an hour or 1 hour grace time, that it's a cloudy day, cloud comes, what I will do? Wind velocity is stormy day, I have not predicted that one, and that day is stormy day or wind velocity is less than the expected one. Uh, Forecasted one, then that excuse will not save you from the penalty, right? That is the issue. Now question is that if that situation happens, then who will save you, right? So battery, you cannot use another polluted source there, right? You have earned lot of subsidies from the government because you are establishing renewable sources. So you cannot run a diesel source when it is required, right? So you have to take the help of battery, and battery power, when it is charges, then you have to take the surplus power from the wind generator. When the surplus power happens in a 24 hours, that power to be used for the charging. So you are not depending on any diesel generator like that, right? So then the question is, the thing is that how much will be the battery size? Battery size, I understand that is a kilowatt hour size, but another one thing is very important. If you follow my cursor, that is a bidirectional converter, right? Bidirectional converter, its size also a issue. So when I say the battery bank size, I will tell that what is the kilowatt hour size of the battery, and what is the kilowatt size of the power conditioning unit. It is called the power in filter. I am not showing filter is also there. Power conditioning unit, right? So if it is a BESS, battery energy storage system, the definition tells it includes battery bank as well as power conditioning system, right? Then the question is, what will be the size of that? I'm not discussing in detail, but one thing is that very important. You have to take the historical data of the wind velocity and wind velocity to be converted to power, and then the forecasted data will give you the committed data, because you are depending on the forecasting data. So, and then you have committed on the forecasting generation, but on the particular day, obviously there will be some forecasting error. Then if there is a error, then for to mitigate that error, how much will the kilowatt hour size and kilowatt? So I refer my paper, you see that one. So it's an interesting work, because nowadays what happens, government tells that if battery bank at peak hours at high prices, if battery bank connected in parallel with the renewable sources, if it generates extra power and government is ready to pay for that, right? So it is not like that. Nowadays the rule is changed. Previously it was happened, battery is a supplementary device, right? Supplementary device means when the deviation happens, then battery gives the extra power to meet the committed one, the rest of the power which is not supplied by the renewable sources. Now, 1 year back, Government of India telling if you generate extra power from the battery bank connected as a supplementary device, I ready to pay that one. So that's why now now we are targeting that what will be the battery size which can meet the deficiency of the committed power, as well as when peak power is coming, peak pricing, high pricing is coming. If I supply extra power, then the committed power of the generating unit, then what should be the battery size, right? So, this one battery size targeting both the cases, right? If you now battery is depending on the SOC, state of charge, right? So if you can take huge amount of power for 2 hours, then price is coming, when high price is coming at after 2 hours, very high price coming at a moderate prices, you are taking more power, the SOC is less. But when opportunity comes for earning more money at 2 hours or after 3 hours, SOC may not be left. But if you increase the battery size to keep the SOC maintained, then cost will be more. So it is a trade-off between cost and profit, right? So now I am going to another challenges that is a inverter limitations, right? Inverter limitations, that is switching limitations. I'm not talking about. That is another one, technical limitations.
పీపీటీ చేసుకుంటా నాకు అప్లై చేసుకుని
Lim-
ప్రమోషన్
tech-
కోసం అని
tech-
రిక్వెస్ట్ చేసి
technical
4 రోజుల కానీ టైం చూసి చూసి నీకు
technical
కొట్ట
limitations is that those who have worked on inverter, there are two types of basically inverters: your feeding mode or grid supporting mode, and grid forming. Three types we have shown here. Grid feeding means that your renewable sources are working on MPPT and giving constant Q. So it is not actually not sensitive. It is not sensitive of voltage and frequency. So whatever the even frequency is less, you are giving more MPPT power, right? You are not reducing power from the MPPT. You are not changing your reactive power generation. If it is a wind based reactive, even if it is if it is a solar based reactive power, you can generate through the DC link capacitors, right? But there is a limitation of DC link capacitor. You cannot unnecessarily enhance the size, right? Then charging time will be more. Anyway, so charging and discharging time will be more. Now you see that. So, but grid feeding inverter will insensitive. It will generate with MPPT kilowatt power or megawatt power and fixed kVAR power. But when you are trying to support the grid, right? Support the grid, you are having a larger unit, having a larger unit, then the grid operator will not allow to run your generating unit on grid feeding mode, right? You have to having a grid support. Inverter should work on grid supporting mode. Inverter should work on grid. So what does it mean? It means that when voltage and frequency changes, you have to change accordingly your P generation and Q generation, right? So even if your voltage and frequency at the connected bus are, suppose one frequency is less at the connected bus, integrated bus frequency is less, it is not for you because you are generating committed power. You have to generate more than your committed power if frequency is less. More than the committed power, obviously it should not be more than your rated power, right? If you are still generating rated power or MPPT power, you cannot generate more than MPPT power. It is true, but if you can generate more power, at that time you are generating less than MPPT power, but you have to raise your generation, right, to MPPT if frequency is less, right? So that's why. But the main issue is here, a lot of people are working on that grid forming inverters. Now you see that inverter is operating, But if you look at the controller, that controller takes the feedback from the grid. So grid from grid it senses how much voltage, how much current, and then PLL gives you the frequency, and then controller takes what will be the desired active power and desired reactive power required, right? That is the whole philosophy. It's a feedback system. Now inverter operates, inverter controller starts working when it takes the voltage and current feedback, right, from the grid side. But when grid is not alive or grid is not connected because some problems comes in the grid side, then then voltage and frequency, if it not received, this controller, if it is not received from the grid, then that inverter will start stop working, right? Because whole controllers will be a mess if the feedback signal not coming to the inverter controller, right? So that's why inverter stops operating, because the PWM signal will not be generated. PWM signal will not be generated, and then that you will not, that gate will not get the signal, right? That is the issue. So now how grid forming supporting inverter, how it transitions to grid forming inverters in quick time. What should be the logic? How it will sense that grid is grid is not alive or grid is not existing? Then how the same inverter working on grid forming inverters without taking the feedback signals is a major issue, right? So there are lot of control topologies. I request to those who are working, want to work. It's a very interesting topic to do research. Now you see, there are a lot of standards, right? Government of India having a standard, but they are basically follows these two standards, right? IEEE standard 1447203 and 2018. What does it actually focuses? It focuses that when voltage and frequency changes, how what will be the reactions from the DER controllers, right? DER means distributed energy resources, right? EPS means electric power system, right? So if you see that, what are the reactions, what are the controllers actions when the interconnected grid, that grid busbar voltage and frequency changes, that guidance is required. What I have told, that you have to, if grid supporting mode, if your size, inverter size is more, then the some specified value, it depends on country to country, then then how much power you have to generate more or how much power you have to reduce, right? That's guidelines are given by that. Very interesting one. So that is, the PCC point where your renewable sources are connected, and they have divided into area electric power systems. Just imagine the distribution networks, right? 11 kV and 414 volt distribution networks. And then some of the generating units are connected. So distributed units are connected. There's a difference between distributed watt and renewable watt, right? Renewable resource and distributed resource. Distributed resource may be a diesel generator if it is connected in the low voltage line, right? If it is connected in the distribution network, even it is non-renewable source, but that will be coming under distributed source. Renewable sources, if it is connected in the distribution source, low voltage lines, obviously it will be coming under distributed sources. So renewable is, there is no chance of non-renewable sources, but distributed sources means all the sources may be renewable, non-renewable, connected in the low voltage network will be considered as the distribution system. So DR connected and area APS connected. Now you see, I want to see something that how much power you have to generate, how much power you have to reduce. So it is a IEEE standard tells that x-axis is the active power, y-axis is the reactive power. The positive reactive power means injection of the reactive power. Negative y-axis means absorption of the reactive power. So and right hand side positive means active power generation, and left a minus active power means active power absorption. So you see that there is a 0 0 means 0 0, you want to say that the base voltage 11 kV system, it is a 11 kV system. So 11 kV system, if it is changed some voltages, some frequencies, because it is not directly related with voltage and frequency, but we have to understand as a power system engineers that so voltage and frequency, if it is changes, you have to change the active power and reactive power. So if voltage and frequency within these two zones, that is a dead zones, we are say P1 dash and P1 and P1 dash. So if that voltage frequency is required that much amount of power, you do not require to generate reactive power. You only generate the active power generation or active power exhaustion. For that voltage, up to that, you do not worried about. P1 is written in the left hand side. So up to that, it is not required to generate reactive power. Even up to P2, then what happens? The voltage is increasing. Voltage is increasing. If you have a renewable sources like wind, then reactive power absorption is required, and the reactive power absorption rate should be at that rate, right? So but how much absorption? Because reactive power absorption, we understand the generator winding will absorb, or the inductor connected in parallel with the grid will absorb, but it having a limit. Generators having a limit to absorb the reactive power, right? So up to that Q3, all the values are written in the left hand side, and up to Q3 you can absorb. After that, absorption power need not to increase. But here you see in this slope it is showing your voltage and frequency both are disturbing. Frequency is reducing. You have to generate the active power. And voltage is increasing. You have to absorb the active power, right? So that slope is actually targeting active power generation and reactive power generation. And the left hand side is a different issue. Left hand side happens when frequency is increasing, absorption happening for active power, and voltage is decreasing. So you have to generate the reactive power depending on that slope. What will the slope value? That is written in one slide. And that is another one mode of operation where you are concentrating on voltage and reactive power. Frequency you assume is very good thing, is good condition, but you are finding your voltage of the grid bus bar is disturbing, not frequency. We know that one in power systems, there are two decoupled equation. One is active power balance equation, other is reactive power balance equation. Active power balance equation keeps the frequency in good health, but reactive power balance equation keeps the voltage in good health, right? So frequency is in good health, but voltage is disturbing. You switch on your controller on that particular mode. You switch on your controller on this particular mode and see that what IEEE grid, IEEE standards tells what should be the ratio, how much support you have to do. Again, deadband up to voltage reference. If it is the voltage reference base voltage, if your source is connected with 11 kV, then your voltage reference will be 11 kV plus minus something. Do not require to change the controller output. But after that, within deadband, you do not need to worry. Do not disturb inverter switching on and off frequently. It will reduce the life of the inverter switches, right? That's why within this zone, very small zone of 11 kV or 415 volt, where you have connected your source, that time you need not to keep busy the controller. Then after that, what happens? If it is V3, in the left hand side, it is written what is the value of V3. Then if voltage is increasing, beyond that, then your reactive power absorption comes in the picture. And the same thing, if voltage is decreasing beyond V2, then reactive power generation following that slope. But how much reactive power generation is then up to V1. After that, no need to worry. You have to keep the same reactive power generation up to that, after V1, right? Right. So that one, so that two slides I am keeping because that same thing what I have told, that I have told you now that how much voltage difference, what should be the permissive just one example I'm giving, if voltage is more than 1.220, means 20% more than your base voltage, then in this zone 5, you have to ride through, you have to support the general grid till 0.2 second, right? And it is called the ride through. Ride through, you connecting up to 2 seconds. Because after 2 seconds, if it is problem is still persist, then you need not to support that one, right? You go to cease to energize mode, right? So that one you just so frequency right through is also here. It is there. It is a 60 figures. It is a nominal frequency. They have considered 60 hertz. That's why one thing is that very continuous. One thing is that you see if 60 hertz is the base frequency, then 58.8 to 61.2. It is a continuous operation. You cannot cease the operation, right? You cannot write through is not a coming question. But if you see frequency is more, then that one, right? Frequency is more means what? You have to absorb the active power. But absorptions of the active power, depending on if it is a solar source, very difficult to absorb. How will your solar panel absorb the active power? It damages the active power, right? So basically, for solar source, absorption part, that part is right. That coming for wind energy, right? That part is coming to the solar and wind both, right? So, but that is the minimum write through time. Now, I want to highlight some of our works. And the question is that lot of things we have discussed already. Now, charging is a load when the EV battery charging mode, right? It's a huge load. Then you see that how much load it takes. The government of India, it is a government of India guidelines I have given in a reference. They are actually coming with six charging power advice. It is a combined. There are AC charging gun having a AC charger facility as well as DC charger facility. Both are having one particular charging station, right? So the electronic circuit, maybe I will show you. Let's see. Then there is another one. See the charge mode it is generated by Japan, from Japan. So their terminology they have used, adopted by government of India also. Their voltage is 200 to 500. It is a DC charging mode, but charger voltage will be 200 to 500 volt. It can be varied. Right, 200 to 700 volt. It is a 50 kilowatt, minimum 50 kilowatt, right? Then one charging gun for four-wheeler. That second one is four-wheeler, higher voltage four-wheeler. Then you are reducing AC charger. You can use AC charger and DC charger. What is the difference? Difference is when you are charging stations based on AC, means you are using the grid power and charging that one and converting grid power to for your charger, for battery charging. So basically your input power is AC, but sometimes if we have a DC power, DC as a source, and then you are using a DC charger, and here the source type 2 AC, here is the source is AC, then you are rectifying, right? But here there is no rectifier is required. Basically buck boost converters are required for this first and two, because it is DC charging, right? Source is particularly DC. Now there are slow and moderate charging stations. Because power is reducing, charging time becomes higher. So that's why they are categories. That fast charging means power is more, current flowing from charger to battery, right? It's a DC. If it is a DC, obviously DC, because battery is a DC load. And then after rectification, if your source is AC, then it is a very simple equation, V1 minus V2 by that impedance, resistance. So voltage, how much you will keep at the source side to get more current to the battery. And then, but again, more current I am telling, but there is a rate. People are telling that C rate should have 0.5 or around to 0.5 to keep the battery health good, right? So there is a lot of regulations coming. Anyway, so now uh, uh, so one work I want to show you, right? One work, maybe I have not got time. Anyway, the work I am doing with my MTech students, that work is still one conference paper. We are trying for the journal paper. But what we have done, what is the thinking behind that? Now we are thinking on, so lot of problems, lot of impacts on the grid, because if at the if when at the evening time period, EV charging stations are consuming active power, and then already load is high, and then this consumption, charging load consumption, voltage degrades, frequency degrades, then lines overloaded, because charging is a big charging stations, then the charging stations, AC charging stations, then the lines connected with these charging stations may be overloaded, right? Because demand at one point, power is coming through that line, it is connected in the distribution 11 kV system. So it's a big issue, right? So line may be overloaded, voltage of the whole systems will be less, frequency for that upward networks will be overloaded. So lot of issues. So what we are thinking on that, let's see a solar charging station, grid independent charging station. So a DC charging station where DC power will be coming from the solar, right? And the battery, right? DC power, and we have taken Ranchi as a location. Why location affects that I will want to discuss in next 4 or 5 minutes. Now see, so in Ranchi, if we are Ranchi main road, if we want to place a charging station, want to install a charging station, set up a charging station, which are grid independent. I will not take any power from the grid. I only depending on the solar and the battery. So now the first question comes to my mind, that how much battery will come to my charging station throughout the day for charging. So what problem that the problems people are solving, that problems they are taking some historical data, then they calculate some probability distribution function, you will get that power. But what I have considered here, I have considered that I have a parking slot I have, right? And parking slot, that cost I am considered, that office commutators, when they are going to offices, they keep their cars, they park their car in the slot, in the parking slot, and they left the car to me for charging. And when they are returning to the residences, to their own residences, they will take car from me, right? That is the thing is, what we have considered, there is a available parking place I have, and I have a available cars every day, because I have a contact with this type of office commutators, that they every day, if required, they keep my car, they keep their car on the parking slot for charging, and then they attend their offices, right? So now question is that how much number of cars I can charge in a day, because if I take a bigger slots of the parking lot, then the land cost will be more, because I have hired this land from someone, right? Or if I purchase that land, I have taken the loan from the financial institutes like bank. Now question, now that is one issue. So that problem, that is the number of cars, how much I can charge, depending on that how much will be the solar size, how much the solar hours in Ranchi available, then location is coming in picture, how much solar hours are available in Ranchi, and how much battery is there, and battery charge I will do only when we have got a surplus power. So what I have considered, I have a one gun point, means one plug point, which is DC charge, DC fast charging. What I have shown you, there is a 50 kilowatt charger I have considered, and that for 50 kilowatt charger, it requires 50 kilowatt power from the solar and battery if required, because solar irradiance are changing in Ranchi. And then what is the historical solar irradiance in Ranchi at Ranchi location? And then I have considered, and it is a solar, Ranchi is different type of city where you will climates are changes life sharply, right? So that irradiance variation I need to take into consideration. And you see that it's a rainy day, seasonal changes effect I need to consider. But I have to propose one solar size, one battery size for meeting 50 kilowatt power for whole the day. It is not possible at all because solar irradiance is changes, right? So now consider is that how much, what is the profit maximization comes in the picture, right? So what will be the one solar size which can give you more profit, considering the parking slot, solar cost, battery cost. So what I have considered, I have seen when I'm analyzing the data of the solar power in different months, in 12 months, I have found one important characteristics. My demand is 50 kilowatt. Sometimes I'm getting, if for a particular size of a solar, right, that is a profitable size, even it is a profitable size, that profitable size will not, that is the main thing, that profitable size will not meet always 50 kilowatt. Sometimes it meets, it generates more than 50 kilowatt in the month of May, but in the month of July, rainy day, in the month of December, very cold day nowadays in Ranchi, right, it generates less than 50 kilowatt power. But it is a profitable. My genetic algorithm solution gives it's a profitable unit because profit earning, because revenue earning is coming by charging the car owners, right? What is the rate? Rate is very competitive. If you keep very high rate, no car will come to you, right, for charging. So now your competitors is grid power. So what I am considered, I will not charge the car owners, which is more than the rate, should not be more than the tariff, electricity tariff prevailing at Jharkhand, right? So my competitors is grid power. I will not the grid power, but still I want to show that still if you are not grid power, you can earn profit. That is the solution exists, right? Solution exists. The problem is coming that you can ask a question that, sir, how you can charge electric cars throughout the day, including the night time, right? So if you want to charge the car throughout the night, then battery size will be big issue, right? My now focus is, because I have just started the work, one only conference paper I have published. So my current focus is that during the solar hours, I will charge the cars, electric cars, and in what will the battery size to support this 50 kilowatt uh, charger power during these solar hours. But interesting solutions, still I have not, you will not get this conference for this type of results. Still I am thinking that interesting solution is that in the month of May, the profitable battery size, again the optimum battery size, my optimal battery size means that profit maximization equations gives me that in the month of May, if you use that particular battery, optimal battery size, you can go beyond the 4 o'clock. 4 o'clock, till 4 o'clock in Ranchi, that is a solar hours is very less, 9 to 4, right? So beyond 4 hours, but that solar hours, so that battery, profitable battery size can be utilized very good, nicely in the month of May, right? Sometimes it is a less than 50 kilowatt, but If it is in less than 50 kilowatt with the help of battery, then your charging time will be required more, your profit coming down. But if you want to keep more than your profitable size of solar and battery, your cost will be more. So that type of solutions I am not going. So these are the equations. These are the equations how to calculate, right? If you that is a estimation. All the things I have covered. All the things I have covered. I have got three types of car. I assumed is available in this in my parking slot. Different types of battery size. Anyway, so profit calculation. That is so another one. That's another one solution. Another one solution I want to tell you that in China it is very popular. Battery swapping, right? Battery swapping is very popular in China. Government of India, they also admit, they also tell that no, for high range car and buses, e-buses, battery swapping is a solution. They admit, and their document is showing that battery swap. What is battery swapping? Because charging time, it's one limitation why electric vehicles is not popular still in India. One limitation is the charging station limitations. Another limitations is the charging time is required, right? A good amount of charging time. It is not that charging time is not required in petrol run cars, right? You go and within a second, within a 2 minutes, 3 minutes, full tank is happening, right? By fuel, right? So, but charging time, that is another one limitations. People are very busy. They cannot wait for 1 hour charging time, right? Now, what that solution or giving solution in China, it's very popular in China. You come to the swapping station, you give the discharge battery to them, and they will in return give you the charged battery, and for that they will charge, right? So battery, when you purchase the EP battery, battery with car without battery you purchase, EV car without battery you purchase. So you have to contact one nearby swapping station, and they will put the battery. Maybe car showroom also can be a swapping station. So they will, but that time there will be a swapping station, right? Swapping station will put a car. Now you start running this car, then when battery is discharged, you go to the nearby charging station, not charging station, swapping station, and they will give you a battery, charged battery, and take away your discharged battery, right? So issue is different, right? That I have given this problem to my BTech students, right? And they are giving a good solution. Still we are preparing paper. So solution is, problem is, that how you can track the battery, who has invested. One person has invested the battery, new battery, one person has invested, right? And that battery users are different now, right? That same battery used by me, maybe next day you have gone and they have used that battery, right? Charge battery, you have the same battery you have taken, right? So users are different. But when that battery tracking system is required, that I want to say, still I am working. Every battery should be tracked. Every battery should be tracked, and every swapping money should be gone. Who has invested first new battery, right? Money should be gone to them, right? To him or her, right? So who has first battery, who has given to the swapping station, first swapping station, right? That battery for you, when you have purchased a car and you have contacted a swapping station put in battery to you, but that is not your battery. That is for battery, maybe for 400 kilometer, right? So, but after 400 kilometer, when you traveled, you are not going back to that particular swapping station, because by this time you have gone to Lucknow, right? From Ranchi. So from Lucknow, you have contacted another swapping station, and then you have handed over that battery. That battery owner is a Ranchi swapping station, right? But you have handed over to the battery, which is located at Lucknow. That Lucknow battery has taken the Ranchi battery owner, that battery he charging cost to be given to him, and discharge and charge battery given to me. That original charge battery which I have got in at Lucknow, its original battery charger maybe at the at maybe at Bombay, right? So now question is that when I am taking a battery, I am taking a battery for 400 kilometer. I will not paying the full money to him because only that battery I will use for my next 400 or 300 kilometer, right? So I am paying the partial money to him. Now how much partial money I will pay? Then this battery is actually moving to different car owners, right? But every swapping, the money should go who has purchased for this battery for the first time. That is the issue. So battery tracking is required. That is an interesting solution followed in China, right? Which are actually saving lot of time. If you can track the battery, right? That is a lot of issue. Battery theft also issue. Anyway, still they are doing. Now you see that I have been told to coordinator some sort of क्या बोलते हैं patents, right? You show, patents you show. So I have searched and coordinator also given me some patent equation. Patent received by Indian professors and American professors, industries. Some of them I'm showing Bhim Singh. It's a very microgrid controller framework. He has got a patent, right, with his student. So what they do actually, basically I've searched that where this work is published. So you know that before publishing paper, you have to apply for patent. If it is published, that cannot be patented, right? So afterwards, they have published their work after receiving the patent, and I have seen that is a conference paper, right? So whatever you wish in India, Indian patent is very easy to achieve, right? So what he has done, I have seen the conference paper that what is the battery size, that IEEE, what I have told you, 15472018. Just some slides I have shown. They are following that one, that what will the controllers actions, what will the controller designed, right? If you want to follow 15, what I have told, voltage drop, frequency drop, and then they have got a patent. It's not a very important patent. So important patent you see. I have told you now that I think that one. I have told you now that universal charging system. Who has got that patent? You see that a charging station, a charging station, same charger can charge AC car same charger can charge using the AC power or using the DC power. Same charger can charge using the AC power as well as DC power. Okay. 1 minute, wait. So it is called universal charger. So input may be AC, input may be DC, right? Input may be AC, input may be DC. So see the circuit. Very important, right? So koi car company. So we are paying money for that. 2012, they have solved this problem, right? Very easy, but you see that what is the importance of the patent. Now it looks easy, but in 2012, lot of, so DC to DC converter, DC to AC converter, they are using AC interface, and you see the DC interface, there is a controller which controls the inverter, rectifier and all, and maintaining the DC charging voltage and AC charging voltage. That is the circuit. It is available, right? If you say now, if you give this a patent application number and all, Google.patent gives that I've collected from there only, right? US patent. So it is the patent of fast charging patent. In which year? 2012 again. All US patent, right? See the importance patent. Every charging station using the same thing, paying money to US. Ford, they have got that patent, that how you can, there is very interesting patent. What is the mechanical way to removing a battery? That also a patent. Ford got this patent. So I think that I have more slide. Let me check. So this one of the works that is your. I have got my group got money, received money from Ministry of Power, Grid Controller of India, to check that what is the battery performance. What is the battery performance when battery is an ancillary service, right? Giving ancillary service. So when voltage and frequency fluctuation is very fast, then battery response time they want to see, check, right? So they have given data, Eastern region grid data, voltage data, and then we are trying in per unit, we are trying that how much my battery is supplying power, and also they want to check that when price is high, energy arbitrage mode. When price is high, battery give power. When price is low, battery charge power, grid is charging power, right? How fast the response it is. That is their main aim actually, right? So that type of curve. Anyway, so I think time is over. So these are the reference, and thank you very much for patient hearing. Thank you very much.
Thank you, sir. Thank you, sir, for such a detailed and informative session. I would request the participants to please unmute themselves if they have any questions to ask.
Yes.
Session is now open for questions.
So there is no question. Thank you very much.
Sir,
Yes,
sir,
yes,
just one question.
yes.
Good afternoon, sir.
Yes. Good afternoon. Yes.
Sir, my only question is that in last session, we were discussing about swapping of battery, sir.
Yes,
How we
yes.
ensure while swapping uh, my battery performance and the battery I swapped will be obviously either up or down in matter of static charge and static field. Then how we
Right,
will ensure, sir?
right. What it is not clear, but his voice is breaking. But what I understood that how a car owner will understand that what is the battery condition. We say in terms that
Yes, yes, yes.
the state of health condition, right? It is said state of health condition, health conditions. Now that research paper tells that health condition, if it is 60% SOH, right, then
Mhm.
battery is dead, right? So what we do, every swapping, when you are going to the car or swapping station for changing the battery, then
Mhm.
the discharge battery, when you are giving to swapping station,
Mhm.
they do a calculation, right? Papers, we are taking the help of the papers. What is the SOC, versus number of cycles, right? We have assumed that
Okay, sir.
number of cycles, battery, how much current is discharging while driving the car, every second data, BMS, battery management systems, it is available, right? So that data,
Okay.
it's not a very big issue. That data is downloaded from the battery management system, and
System.
there is a SOH calculation depending on the driver's nature, because current discharging depending on the car drivers, right? The driving behavior. So accordingly, a particular equation is there. If you set this in this equation, within a minute you will get that how much SOS is lost for this for driving this, for using this car in the last driving. But so that del SOH, how much, because it depends. That is a very important, that is an important issue, that SOH degradation depending on the car driving behavior, right, of the particular car, right? So because the discharging current variation affects the SOH. So that what we are trying, we have considered that driving car behavior depending on the discharging current behavior, every sampling time is available. Equations are there. SOH calculation we can do del SOH. Previous car del SOH, previous users of this particular battery SOH, and the current SOH. So del SOH will give you that particular car's last SOH of that particular battery. So accordingly, we are charging these customers, right? SOH is also a factor. You are correct. SOH is also a factor charging car owners when he comes with the discharge battery for changing. That is also your estimating, right? That is a very important thing. And there are a lot of process, right, to calculate SOH. SOH calculation is very, very typical task in this work, right? That is an issue. So SOH we are calculating for charging the car owners.
Got it, sir. Thank you.
Right. Thank you.
Hello, sir.
Yes.
I have also one question, sir,
Hmm.
related to the swapping of batteries. Sir, the concept of battery swapping is not so popular in our India, so it's difficult, and how difficult is it really to convince all the major EV makers to agree on one or major standard battery sizes and shapes, sir? And what happens if a
Right.
battery is only the centimeter too wide for a particular bike model or EV model, sir?
Right. I've checked. I think that which one, which reference is given. So that is standardization of battery is very important. I understand that
Exactly,
one,
sir. This is
right?
my question, sir.
Right.
Yes.
So standardization battery, there is a one document I have not given. Government is forming a committee. Actually, they are looking for that, right?
Yes,
Say
sir.
lot of different cars, different battery, size of battery,
Exactly.
different length of battery is very difficult. Give a solution for battery swapping. How many types of battery a swapping station owner will keep? That is a big issue.
Exactly, sir.
That is a big
Exactly.
issue. So Government of India forming a committee for standardizing of battery size and dimension, as well as size means kilowatt hour size, right? So Government
Okay,
of
sir.
India is working on that. Is a hidden one. For swapping is not so much popular, but you see,
Exactly. Exactly.
if government is coming out with that solution now, then swapping station will be a very good, establishing a swapping station, giving a swapping station a very good business solution. I am telling you, right?
Yes, sir.
It saves lot of time as well as grid problem, right? Grid problem,
Yes,
voltage
sir.
degradation, frequency degradation. Because swapping stations owner will charge the battery, but he is very intelligent. He will not charge the battery at peak time. He will charge the battery at the late night when price is very less.
Exactly.
Thank you.
Okay, sir.
Thank you, sir.
Mm.
Thank you all the participants, and thank you, respected host, sir,
Mm.
who you have kindly accepted our
Right.
invitation and
It's my privilege, Dr.
spared some
Acharya, mane
time from your schedule, sir,
sharing
to
my
share your
thoughts.
experience and knowledge.
Right.
Thank you very much, sir.
Thank you.
I request all participants to please switch on their cameras. Sir, I would
Oh,
also request you to please switch on your camera
I am
and
not
take
in
a.
a good, I am not in a, today is Saturday, so I am not in
Acha.
proper dress and all. Anyway, give me 2
Okay, sir.
minutes time.
Yes, sir. Okay, sir.
Hello.
Yes. So switch camera switch on. Where is the camera? Here, right. Turn camera on. No. Turn camera on. I'm doing, but 1 minute. 1 minute. Yes. Hello. 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 Yes.
Yes, sir, your camera
Yes,
is
sir.
on
You
now.
are,
Okay, sir.
Sir, you are
you are
audible,
We
sir.
will
visible.
Audible,
just
sir.
take few screenshots.
Okay.
So everybody please allow me few minutes because I have to take 3 or 4 screenshots. Thank you, sir. Thank you all the
Thank you.
participants.
Thank you very much.
Thank you very much, sir.
Thank you.
Thank
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you,
Thank you so much, sir.
Thank you.
Thank you, sir.
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 Sir, thank you so much.
Very much. Sir.
So, dear participants, as per the schedule, our next session is was supposed to start from 3:30. So we will start now. The next session is on topic towards resilient active distribution networks by Dr. Mrs. Devamita Ghosh, Associate Professor, Electrical and Electronics Engineering Department, Builders of Technology, Mesra, Ranchi. I am happy to say that Madam has already joined our session. Ma'am, it is an honor to have you among us. On behalf of the organizing committee, I extend a heartfelt welcome to you.
Thank you, Dr. Deepshekhar, for this invitation. I am really privileged that I'll be able to give my views on the topic of FDP. So
ma'am.
shall I start straight away or
Ma'am,
there
let
will be
me
some
formally
break?
introduce,
Yeah, okay.
then you may start, ma'am. So participants, we have among us Dr. Mrs. Devamita Ghosh, who will be delivering her session on the topic towards resilient active distribution networks. Dr. Devamita Ghosh is an associate professor in the Department of Electrical and Electronics Engineering at Birla Institute of Technology, Mesra, Ranchi. She received her BTech degree in Electrical Engineering in 2006, followed by Master of Engineering in Power Systems in 2008 and a PhD in Engineering in 2014, all from BIT Mesra, Ranchi. She has over 17 years of experience in teaching and research. Dr. Ghosh has published around 90 research papers in reputed international journals, transactions, conferences, books and books chapters, including IEEE Industrial Informatics, IEEE Systems Journal, IEEE Sensors Journal, IEEE Protection and Control of Modern Power Systems, IEEE Access, Nature Portfolio, Reliability Engineering and System Safety Elsevier, IJEPES Elsevier, Springer and Taylor and Francis. She has received multiple externally funded research grants from Coal India Limited, the Eastern Regional Load Dispatch Center, Grid Controller of India Limited, the Ministry of Power, Government of India, and Typhoon Hill, Switzerland. She holds 7 granted or published national and international patents and has supervised several PhD and MTech and undergraduate students. Her research interests include power system reliability, smart grids, system integrity protection, wide area monitoring systems, energy management systems, and applications of artificial intelligence in power systems. Ma'am, it is an honor to have you among us. I request you to please start your session.
Thank you so much. So I'm going to start with my session. So just sharing the slides. I may need to keep my camera off because of the data issue. So at the end, again, I'll be switching off on my camera.
Okay.
If the participant have any query in between, you can stop me and ask. So thank you. Is my screen visible?
Yes, ma'am.
Yes, ma'am. It is visible, ma'am.
Okay, thank you so much. So, as the topic says that the topic given for discussion today is towards resilient active distribution network for this 5-day FDP program started from 8 December and today is the last day. So straight away I'll move to the what active distribution network is, followed by what is the need for this resiliency in active distribution network. And definitely, I'll talk a little bit on how we can apply patents, utility patent as well as design patent in this relevant field as well as subsequent other field of interest of the participant. So, as we all know that with the
Excuse me,
increase.
ma'am.
Hello.
Ma'am, have you started the presentation?
Yeah, I am in my second slide.
Oh, no,
Is it
ma'am. Here
No,
actually
ma'am.
the slides are not visible.
slides are
We
not
are able
visible?
to see the MS Teams window.
Okay, I'll just reshare as shared actually. Share my entire screen, right?
Yes,
I
ma'am.
should share my entire screen.
Yes, that will be good.
Now,
Yes, ma'am. Yes, now it is visible.
yeah, first slide is visible, right?
Ji, madam. Yes.
Okay,
Yes, ma'am.
okay. So I am moving to my second slide, which is the beginning of my first slide of the presentation today. So, as we all know that the demand is increasing constantly and we have to meet that particular demand. So our concerned supply also has to be in par so that this supply demand problem can be enhanced or it can be made equal, mitigating the losses. So conventionally, we know conventionally the generation, if you see in the 18th century, it was steam-based generation. That was followed in the 19th century to 20th century, electricity mass production started. After which, in late 20th century, the knowledge of computer came up. So the later focus in the 21st century was to integrate the computing knowledge along with this concept of generation. So AI, big data information, cloud computing, IoT, along with generation was integrated so that we can call the grid smart, and we can meet the generation, uh, we can meet the demand as per the generation by using the renewables also along with the conventional sources. So if you see the conventional typical layout, this I think those who are from electrical engineering background are very much aware of this particular layout, where we know that the conventional generation is from the power plant and then gradually transmitted to the transmission lines, sub-transmission system, and finally we are the consumers. It can be an industrial consumer or it can be some domestic consumers. So this is the conventional power flow, which was unidirectional in nature, from generating station to the distribution. But with the boon of this IoT and the grid becoming smart with integration of renewable and modern sensors, the convention changed. So this is the typical layout of distribution network, where from the high voltage or medium voltage substation, we were getting to our households, whether it is rural or urban region. And this is the layout of the active distribution network, where you can see certain additional parameters. Initially, it was just the power was coming in and we were using it. This is the flow. Now, if you can see, it is behaving like a ring. And it is, if these are the loads, different loads, you can see that load management strategy is done, and integration of solars, wind, these are the two major partners for renewable along with storage devices. So EV vehicle charging station, the industrial generation with the conventional sources. So these ADN or active distribution network constitutes of over the convention, you have the integration of the renewables also. So the entire power flow, which was unidirectional, became bidirectional with the boon of the sensors. So that led to the concept of microgrid from the active distribution network. So this is the typical layout of the active distribution network. So the moment the power flow became bidirectional, the protection challenges was a major challenge, as well as challenges related to the grid to behave in an islanded mode as an islanded microgrid system or an integrated mode. So certain challenges came up based upon which various research works are being done in presently. So this is the data which has been taken from Ministry of Power, Central Electricity Authority. So if you can see over here, it is the targeted installed capacity of in megawatt up to 2030, where you can see that the solar is sharing around 34% of the generation, wind sharing 17% of the generation, along with biomass and small hydro projects. So it is almost, we can see that if you take the non-conventional sources, it will be almost sharing 50% of the contribution over the renewables, over the conventional sources. So this is what we are telling, that this is sharing a major part, means this will be the integration towards the distribution network, making it active in nature. So now, as I said, that certain challenges will be coming up the moment when we are looking into, when we are moving ahead from conventional distribution network to an active distribution network. So one of the major challenges is energy management. So energy management around the globe is increasing exponentially. This is preservation of the devastating climate change, the net zero carbon emission by 2070 as per the government concern, the consumption of fossil fuel will be gradually phased out, and inclusion of distributed energy resources, especially in the distribution system, is an urgency of the current time. And but it can lead to various issues and complexities. So to nullify these issues, one of the matter which should be taken care, various matters are there, various things are there to be discussed. So one of the thing which I have chosen as a part of the discussion today is what we are telling: to nullify the adverse effect of distributed energy resource integration injection, it should be limited to its hosting capacity. So what this term is, I will discuss further. So this is one of the important aspect which should be taken care while we are in the process of integration of more and more renewables into the distribution network, making it active. So as I said, the hosting capacity, it is defined as the maximum amount of power that can be connected to the system without disturbing the power system parameters. So what are these parameters? The fundamental parameters being the voltage limit, the current limit or the ampacity of the conductor, and the power quality. By power quality, majorly we are focusing on the harmonic content. This is what we are calling as hosting capacity of that particular network. So it is simply telling that we will keep on integrating the renewable, that is fine, but we have to limit it based upon the three major conditions. That is voltage, it should not violate the voltage limit, it should not violate the ampacity limit, and it should not disturb the power quality. Considering these three aspects, if we can integrate, then that is what we are telling as hosting capacity, which will be one of the key aspect of energy management. So here I have given an equation for the same, and another term I am coining it as enhanced hosting capacity. Actually, I am claiming it that I am coining because this is one of the coined term in our published paper. I have referred at the bottom. So enhanced hosting capacity, it means that the injection beyond the calculated HC as per this above equation or as per this above definition, maintaining the power system parameter within predefined range, is what we are calling as enhanced hosting capacity. Right? So what is the difference between this hosting capacity and enhanced hosting capacity? It is meaning that here the hosting capacity in general, as per the existing literature, says that you are calculating the amount you will be injecting based upon the voltage limit, current limit, and power quality. But when we are planning it, that particular injection uncertainties or variabilities are not taken care. So if those aspects are also taken care and then we reiterate it after planning stage, that is what, without violating again the power system parameter, is what we are referring to as enhanced hosting capacity. So this is a typical layout for the same. If you see over here, this is the grid or the utility, and here a particular single bus, two bus system is shown with an R equivalent and X equivalent, or the Thevenin equivalent of the network. And here at the PCC, you have a generation from the solar and the load. So if you can see over here, the power flow animated is bidirectional in nature. That means the solar can also contribute to feeding the grid as well as feeding the load. So if this process is followed, keeping without violating the voltage limit, current limit, and the power quality limit, that is what we are claiming as hosting capacity. And if you are going, if you are sustaining this low voltage limit and high voltage, this animated figure I'll just show. I have taken over here. This is the conventional profile which you get to see in terms of hosting capacity, right? So in the x-axis, it's telling hosting capacity. In the y-axis, the primary parameter considered is, or the indicator considered is the voltage profile. So conventionally, it is said that if you this voltage profile, this HVL is shown, high voltage limit. So if you inject it beyond that particular limit, that is what we are referring to as uncontrolled power injection. And if we can keep our injection within this particular box, the upper limit is the high voltage limit, and this right limit is the hosting capacity limit. So this is what we are referring to as the controlled power system, where we are integrating the renewables limiting the hosting capacity with respect to the voltage limit. So if voltage limit is taken care, by default, the current limit and the THZ limit will be taken care. That is what the conventional literatures are telling. So what we have done in our work is that we are telling that that we will not feed. We have, instead of a high voltage limit, we have given two limits. One is low voltage limit and another one is high voltage limit. And over the calculated injection, we have added a restructured injection. If you can see over here, improved DG penetration due to restructuring. So I'll talk about what restructuring is. So what we are telling is, instead of limiting into a wider range, if we can limit to within this particular band, this particular box, then our operation becomes more controlled and more easy to maintain the stability of the system. So we have proposed in our paper that we will limit it within high voltage and low voltage limit, and the injection changing from the calculated hosting capacity to a restructured hosting capacity. So we'll see what it is in this particular figure. So here, if you see that this is my test system, what we have considered in our paper. So this is an IEEE 33 bus distribution network. Typically, you will get to see this figure in different research papers. So what we have done over here is, in the research papers, they are telling that if this is the utility and this is 33 bus network, they are proposing certain specific location based upon optimal location of solar PV. But what we did over here is, as we have coined the enhanced hosting capacity, we have simply put the solar PV at all the nodes. It is not a practical solution, I know, but we have simply tried to analyze if we are incorporating the solar PV at all the nodes with loads at all the nodes, then how the system is behaving. Is it violating the voltage limit? Is it violating the current limit? Is it violating the quality of the power? So what we found, that when we tested this system for a 12.66 kV standard, we found that for different power factors, 0.8 power factor, 0.85 power factor, 0.9 power factor, it was showing that these are the voltages. You see, 12.66 is my standard voltage of this particular network. And you can see that for the different power factors, we are getting a voltage somewhere around this 12.66, but we are not, here I have not shown the bound. Upper limit, what should be the upper limit or what should be lower limit. Simply I have shown, I have obtained we have obtained our results that for different power factors, how this particular system is behaving with respect to the voltages. So the same has been shown, the major variations in injection, only those, instead of showing the injection for all the buses, the specific buses are shown in this particular table. Why? Because the reason is, because in these specific buses, the injections were more compared to the other nodes. So this is what we have done initially. So after doing this, what we have done is, we have reconfigured. As I said, I'll just go back to my ninth slide. I hope it is visible, ninth slide. I'm presently in my ninth slide now. So what we did, as I said, that on restructuring, we can limit it within this particular smaller box. So the same has been tested by simply reconfiguring or restructuring the network. Initially, the base network was this, right? And now what we did the tie line switching, and we have reconfigured the network, right? So after reconfiguring, we again tested with the same pattern of our injection, where the solar PV at all the nodes, the load at all the nodes with the utility connected. And again, we have seen at different power factors. So when we compared the voltage profile by the base and the reconfigured network, you see here it has been shown, the voltage limits are shown as per the IEEE standard 519 standard. So the upper voltage limit has been shown by a green line, and the low voltage limit has been shown by a magenta line. And the voltage profile for the reconfigured network is shown by a blue line, and the voltage profile without reconfiguration or the base network is shown by a red line. So when we compared, we found that when we are doing this injection at all the nodes for base case as well as for reconfigured case, bus number 2 to 7, there was a violation of low voltage limit. So this was the contribution over the existing work. So the moment we found that the base configuration was violating, and after reconfiguration it was within limit, we proposed that yes, that if we are planning for injection at all the nodes without violating the voltage limit, the current limit, and the THD, the reconfigured configuration of the 33 bus network is a better approach over the conventional base network. So this was the major comparison, major contribution of this particular work. So the same thing was modified, and modified, I won't say modified, the same thing was tested on a hardware in loop platform by using Typhoon HIL. Typhoon is one of the emulator which we have in our lab. So in that we have designed this particular model. The software is very much similar to a Simulink platform. People who are aware to use MATLAB Simulink can typically rebuild the model in the HIL software and validate it in the hardware in loop emulator. Typhoon we have done for this particular case. So it's the same 33 bus network has been simulated. For what condition? It is written, despite the fact that the HC is calculated at planning stage, due to uncertainties associated with renewables, renewable sources, loads, and power system parameter, dynamic HC need to be considered. So for that, we developed this particular HIL model to test that whatever dynamism is coming up because of renewable uncertainty, renewable uncertain behavior, load change behavior, or power system parameter behavior, we have modified our work to another conditions, what we are claiming as dynamic hosting capacity or dynamic HC. So this dynamic HC also referred to as operational hosting capacity. We have optimized that. So the initially when we were telling, when initially if I go back to my 9th slide again, you see our objective was to limit our operation to within this small box. Now further we modified that we will control it in such a way that we can limit the operation in such a controlled manner that it does not violate the operation when the dynamism is also taken care in the operation of the source or the load. So if initially this box we magnified in this over here, you see over here, and we have done what? This is the operational region we have proposed, and then finally the optimal operational region has been shown over here, OOHC. OOHC. What is the reason for shrinking the operation to within this particular zone? The reason for shrinking this particular operation within this particular zone is because the uncertainties are coming up. So what are these uncertainties? The uncertainties are in this fashion. If this is my the fundamental equation of my generation meeting the load of hosting capacity, we have included a regulation factor, and with that regulation factor we have varied or we have tried to limit the voltage within the standard range. We have tried to limit the current within the standard range over here, as well as the amperes, THD within the standard range. So we have incorporated certain regulation factor based upon which it will be possible to operate within this yellow zone FIGJ, so that this particular allowable values as per IEEE 519-2014 standard can be considered. You can see that the dynamic customary operational hosting capacity, the buffer range considered for EHC, as we have proposed in the paper, as 1 to 9%, and the regulation factor for voltage 0.1 to 2%, that is plus minus 5% as per the allowable 519 standard, the current plus 5%, and THD 0.1 to 0.5%, that is plus 5% as per IEEE 519 standard. So keeping this buffer range into our regulation and the controller, we managed to operate within this particular operational hosting capacity range, and the controller developed was successful, which we patented it. So this is the patent part. As we have tested, so our controller was basically this is the controller part. So this is the hill, the ash colored box. You can see the ash colored box. This is the hill 602, and this is the breakout board, hill breakout board. So our system was developed virtually. Our system was developed, that 33 bus network was developed virtually. However, the controller was was developed in the TIC 2000 card, and the controller was interfaced. So basically, we did the controller hardware in loop, and the controller developed was patented basically in one of our patent, a system for promoting and management of renewable energies. So the major idea was the development of the controller and testing the controller in CHIL platform for the same concept as I have shown over here, considering the dynamism of the source, the load, and power system parameters. So later on, if you move further in the topic, so as I said, that the uncertainties have been tested, and we went on for patent. Now, considering these uncertainties into mind, we have to see that whether how much reliable or how much resilient our system is, right? So for that, what we did, we have the hosting capacity, what we have calculated, we have moved it further. We have done a further injection, keeping the dynamism of generation into aspect. And we re-evaluated the hosting capacity by variation in power injection due to the intermittent nature of SPV. We have tested this model actually with solar PV. So that is why I am talking about the intermittent nature of SPV. And we have tried to analyze if the intermittent nature of SPV is taking care on the same box as we have considered from the beginning, then how much operational reliability is sustained within the system. Maybe it is not violating the power system parameter, but is it reliable to run that particular system over a long period of time? That is what we have tried to analyze. So just a brief of, just a moment, okay? Yeah. I just want to show my hyperlink. Yeah. So just a brief about what a reliability is. It constitutes of the probable components, that is probability, durability, dependability, quality over time, and availability. So it is basically a ability of an item or a system to perform its intended task under certain conditions for a stated period of time. So that is what the fundamental definition of reliability is. So here in our work, we tried to test the operational reliability. So I'll just quickly go what I mean by this operational reliability from this particular operational diagram. So if you see the first diagram, you see in the x-axis time is shown, in the y-axis operating, it is just showing operating, right? For figure A. So it is, the figure A is termed as mission-oriented system with no idle phase. For example, a fighter jet, right? So it should operate when it is intended to work. When it is supposed to work, it should be in operating phase. When it is not supposed to work, it can go down, it can fail, no issue. So, but it should not fail in its due course of operation. So that is what is termed as mission-oriented system. Now, that figure B, if you see, it is mission-oriented system with idle phase. For example, the very common example in power system is operation of circuit breaker. Circuit breakers are commonly available in our household also, MCBs. So MCBs are in normal conditions is idle in nature. It is not functional. But whenever fault happens, it should be functional. At that time, if it is not functioning, it will lead to short circuit of your entire household or the operational appliance or the particular location of its application. So that is what is termed as mission oriented system with idle phase. The first one is without idle phase. The second one is with idle phase. And if we consider our grid, it is a continuously operated system, the last case. That means it is operating, most of the time it is operating, where if it is failing or if any particular part is failing, it will fail, but it should be restored back as quickly as possible. So failure period should be very nominal in nature. Right. So that is what we tried to analyze as the operational hosting capacity in our work. Right. So I'll just quickly go to what I intend to. For example, this is a particular, let us say, a transmission. If I consider a particular transmission line, a single transmission line. Now, a single transmission line uh, can undergo its operation in normal weather condition also, because it's an outdoor equipment. It can go, it can work in normal weather also. It can work in stormy weather also, right? Or it can fail in normal weather also. It can fail in stormy weather also. So this transition from failure from normal weather to operating in normal weather to failure in normal weather, and vice versa, the weather transition from normal to stormy, or and the operation from in stormy condition to a failure in stormy condition. This transition modeling is the conventional way to analyze the reliability of any component within the power systems. Right. So I'll just go back to my original slide. So here what we intended to, by varying the power injection due to its intermittent nature, how much operational reliability or how much it is depending on the grid without violating the power system parameter was our major target of discussion. So here again, what we did over here is we extracted load data from a particular literature, and we have used the solar irradiation data from the 1 megawatt rooftop solar panel. This rooftop, by rooftop, I am meaning that in our institute, we have this 1 megawatt solar panel, and we have the access to get the data from that particular 1 megawatt panel. And we integrated the load data and the solar data, both the datas. And what we did over here is we did two things. One is the first thing what we did is the load profile and the solar profile. We have using a particular method, what we are referring to as Monte Carlo simulation for operational reliability estimation. So what we tried over here in simple language is we have got the load data, we have got the generation data. We have tried to match whether the load data, the generation data is able to meet the load data in simple terms, keeping the voltage limit, the current limit into aspect. So the conditions of voltage limit and current limit into aspects are taken care. The details of what Monte Carlo I am not discussing, but that is the essence of this particular work, this part of the flowchart. And this part of the flowchart shown in green, here we have done the same mechanism as we did for looking into the hosting capacity assessment, that whether the voltage limit and current limit and voltage profile are in the real-time platform. So we have simply integrated the dynamic hosting capacity in the real-time platform, keeping the voltage limit, current limit into consideration. And we have seen the reliability by Monte Carlo simulation, keeping the voltage limit and current limit into both of them. That is what we did in this particular work. And we are claiming that this is the flowchart for assessment of effect of dynamic hosting capacity on operational reliability estimation of an active distribution network. So the simple thing is we have added this particular part, keeping the operational reliability in mind. So in the same has been shown in this particular flowchart. The thing of discussion is how we will estimate that reliability indices, reliability parameters. So the estimation was done by certain indices, that is dynamic DLOLP, dynamic loss of load probability, dynamic loss of load expectation, dynamic loss of load duration, dynamic grid margin, and dynamic grid dependency. Now, what are these? The simple term of loss of load probability means what is the chance that you will not be able to meet the load demand. That is what loss of load probability means, probability of losing the load. Why dynamic? The reason for dynamic is because we have taken the dynamic parameters that our generation will vary throughout the day, our load will vary throughout the day, as well as if you are considering for a particular day and extend it to throughout the year, so the possible variations will come in year around also. So that is the dynamic loss of load probability. Dynamic loss of load expectation means how much loss of load you are expecting dynamically, keeping in mind that the possible expected loss of load may be met by the grid or by an alternate source. So that estimation was done. Dynamic loss of load duration means loss of load duration means how long, if you're losing a load, then how long that particular load will be out, how long you will not be able to meet the demand from your solar PV. So that much duration you have to depend on the grid, right? So keeping that in mind, the dynamic grid margin. So what is the gap between your generation from the solar PV and the generation from the grid? That is what we are telling as the margin. That is also dynamically varying, obviously. And lastly, the dynamic grid dependency. So how much dependent you are on grid at different day or different time of the year. So by coining these particular terminologies or the indices, we proposed that yes, keeping the aspects of hosting capacity in mind, we have tried to analyze how much operationally the work will be reliable in nature, so that we can move ahead with the resiliency part. So this is the typical output for the same. If you see over here, for the month of January, February, and March, for the 1 megawatt rooftop, you can see the dynamism characteristic. For January, you have a different generation pattern over February and March. Similarly, for April, May, June, July, August, September, October, November, December. So the generated capacity dynamically was analyzed and was captured and analyzed in the particular from the 1 megawatt rooftop solar panel, and the corresponding voltage profile was tested for the same 33 bus network for 12.66 kV for January to March, April to June, July to September, and October to December in real-time platform. This was done in real-time platform, not MATLAB simulation. So we found that it was sustaining the range of plus minus 5% of 12.66 kV for this dynamic injection also. So that means it is not violating the voltage limit. So now this is the way, this is the flow in which we have captured the data. This is our Mesra main campus, the rooftop. From the SCADA panel, we have taken the data. We have rebuilt that data on the 33 bus distribution network, which was developed in a virtual mode in the Hill emulator, and we have tested the same in the controller. This is the breakout board with the controller and DSO shown. With the integration of load profile also. The load profile was collected from different literature and was integrated in this particular system. So if you see over here, the voltage profiles with the voltage limits, the upper and lower voltage limits were tested. You can very well see that it is sustaining within the upper end voltage, upper limit and lower limit. for all the different months, January to March, April to June, July to September, and October to December. And this is the current injection, right? So current injection was also tested, and this is again the validation through hardware in loop. So it is found within the limit. Also, the THD was, you can see over here, 2%, 3%. So it was not even crossing more than 3 for the various conditions created. So it was well within the standard limits. So now, as I said, after testing this particular the ampacity limit, the voltage limit, and THD limit, the parallel objective was to check upon the dynamic loss of load probability, dynamic loss of load expectation, dynamic loss of load duration, dynamic grid margin, and dynamic grid dependency. So you can see over here, if I discuss with respect to grid dependency, you see the blue indicator, right? So grid dependency for different months, you see it is varying. If you can see, it is varying. It is the maximum dependency was found for that particular data set, what we have collected for a specific year the grid dependency was found to be maximum in the month of September. Now, if you take multiple year data, obviously the pattern might differ depending upon what the irradiation pattern is or load pattern is of that specific time of the year. So this was the proposal actually. So now, having this done, the next target was, which is targeting to the discussion of today's topic also, that resiliency. What does this resiliency mean, and how it can be correlated to this active distribution network resiliency. So in simple, what resiliency means is, I've shown a metaphor of nature. You can see over here a drowned kind of wooden log, and on top of that a new life managed to grow. So this is a resiliency, a typical resiliency of nature. So six icons, story of resiliency, and if you get to see, this is from the internet only, and by Kate Raworth. The resiliency is defined by these following terms. The first is the flexibility to bounce back. Very common example is the jelly. So it bounces back, so it should be able to bounce back. This is the cobweb, showing the vulnerable flexibility. The cobweb, if you see, it will never completely get wiped off, even vulnerable atmospheric condition. It should be able to adapt. The chameleon example, it should be able to adapt based upon the needful change. It should be able to reorganize or self-organize itself, just like the ants. The renewal, it should be able to renew itself, just like the phoenix rising from its ashes. And this is the typical example of persistence of the horseshoe crab, which for thousands of decades it has not changed its structure, but it sustained the various harsh abnormalities of the nature, and it persisted. So it is basically, this term resiliency is nature inspired term, keeping into the perspective of these various six aspects or the six icons into mind. So if we can manage these six icons in our power system network, or in whichever field of application, it can be claimed as resilient. So keeping this in mind, I'll specifically move to this active distribution network. So if you talk about active distribution network resiliency, it should be, the first thing is, it should be able to withstand, right? So taken from these six icons, to withstand means any sudden extreme weather or human attack. If it is occurring, human attack is predominant nowadays, because you are integrating the IoT and the knowledge of AI in a generation platform also. So human attack is a major challenge nowadays, cyber attacks. So it should be able to withstand that attack from the human, or as well as weather. Now it should be able to respond. So quickly restore or bounce back, as I said in the previous slide. Quickly, it should be able to restore the operation after any specific event. It should be able to adapt or change, just like a chameleon, to unexpected and new situation while maintaining its functionality. Its functionality should not be disturbed in any way, and prevent further occurrence it should prevent. So future occurrence based upon past practices, it should be able to prevent itself. So if these criteria are taken care, we can say that we can have a resilient energy management within our active distribution network. So this is a brief comparison because I have talked about reliability also. So what is the difference, specific difference between resiliency and reliability? I will just give a small brief. So here I have tried to show in this way that if you read it like this, extreme weather event resiliency, right? So if you see that it is low for if you go for a resilient condition, the event probability is low actually. However, if you go for reliability, event impact is very high. Event predictability is low for resiliency. However, number of faults is high. Other infrastructure adequacy, it is low, but damage to network is high. And restoration time is also high if you go with resiliency perspective. On the other hand, if you go for a reliability perspective, if you see that, if you read it like this, it is low restoration time, but high adequacy. Damage to network is low, but here other infrastructure damage, it can be high. So accordingly, number of faults, it is low, even predictability is high. So this is the way, this is the major difference, or in other words, the resiliency events, it's a high impact, low probability event, but reliability is a low impact, high probability event, in simple language, if I say. So, how this evolution of resiliency came up and became important for power system, the major challenges what was faced as per the literatures is the different categories of the problems encountered. So if you see the different categorical problems, meteorological problems, geological problems, accidental issues, or malicious attack, so that under that, if you recategorize the types, you will find that windstorm, ice storm, lightning, heat waves under meteorological, geological, earthquake, accidental is fire or explosion, and malicious attack is intentional attack or cyber attack. So if you see the overall region-wise, the affected population, you'll see that year around, you'll see that various major zones of regions or major clusters of humanity is getting affected for a quite several duration of time, right? Yeah, maybe 72 hours, 1 to 2 days, like that. So this was the idea for the different high impact low frequency event. They may be low, their frequency is very low, means they may happen maybe 10 once in 10 year, but or maybe once in 5 year, but their impact is very high. So that is why the our network should be so designed that it should be resilient to operate and respond accordingly in such situations. So these already I have covered. So again, I'm just briefing the resiliency features, that it should be it should have sufficient resource to handle any kind of disaster. It should be robust enough to so that you can endure a low likelihood yet high impact occurrence. Rapid recovery, it should be able to recover itself faster. It should be able to adapt itself to the necessary changes as which is encountered within it. So these are the detailed features which we have proposed in one of our literatures, that it should be flexible, it should be adaptable, it should be robust, redundant, and the capacity should be taken care so which can absorb maximum unexpected disturbances. Interoperability should be there, longevity should be there, and rapid recovery. This is a detailed analysis of the different features of the resiliency. Now, these are the typical characteristic of resiliency. If you see over here, the first one is called the resiliency triangle. Why it is called the triangle? Because its shape is like a triangle. So this normal means your entire system grid is behaving normal, right? No problem encountered. Whenever a problem has encountered, you see a sudden, there is a dip. There is a dip, right? Dip from normal to an unhealthy condition or degraded condition, right? And then it is done what? It is restoring back. It is restoring back and attaining the normal behavior, This is a resiliency triangle, right? So we get to receive three informations, that is normal state of the system, the complete degraded state, and then again restoring back to normal state. So this information was not sufficient enough to analyze how we can look into the restoration process or what was the cause of the problem. So later on, the modification was a resiliency trapezoid. So again, the shape, as the name suggests, the shape was a trapezoid over a triangle. So you see over here, the scenario again starts with normal, then a gradual degradation instead of a steep degradation, right? So gradual degradation means you are building some withstanding capacity or trying to analyze some withstanding capacity within the system. After which it is degrading, right? And it is sustaining its degraded phase for a certain duration of time until and unless the process of restoration starts. So here there was no condition given how to move for restoration, but here you are getting that certain steps of restoration can be done to obtain not the normal state but a pre-disturbed state. Why a pre-disturbed state is important? Because a pre-disturbed state will help us to analyze. It may not be completely normal, but a situation where it is near about to normal condition, where we can start our operation prior to attaining the full normal condition, right? So again, a problem encountered was here also we have to wait till the system reaches this pre-disturbance state, right? So later modification, which is still in research, people are researching in this particular domain, is resiliency pentagon. In the pentagon, the additional feature was this post-restoration state. In the post-restoration state, you can see that it is partially restored and it is robust and resilient enough to start its behavior from here itself. So that is saving the time of operation. Instead of waiting till here, we can start our operation at this phase only and then gradually restore and recover the entire infrastructure. So the more we can detail this particular resiliency curve, the more our operational feature extraction will be smooth, and we can work towards a better and faster achieving our goal of resiliency rather than waiting for a longer period of time. So that was the idea. So keeping this in mind, this is the same difference as I have talked, so I'm not repeating again. So again, the similar thing, we have discussed this. So keeping that in mind, we have tried to analyze that what is the, from the 20 years data, we have tried to analyze for distribution network, what is the cause of major interruption. So we found that weather related causes are sharing 55% of the distribution system interruption. Physical attack was sharing 40%, and then earthquake and additional cyber attacks and all was sharing 5% and all. So distribution side, we analyzed that damage to the pole and line was a major cause. Ground shaking damage leading to underground or overhead lines of the pole damage, underground line impairment due to seepage, and distribution disrupting security and reliability by gaining access to substation. These are the, for windstorm, this was the cause, this was the effect. Earthquake, this was the effect. Flood, this was the effect. And cyber attack, this was the. So the distribution side affected what we analyzed from the literature. This was from one of our literature papers. We have proposed this, that these are the possible distribution side getting affected, and transmission side also we have proposed that these are the possible effect of the HILF event in the transmission and distribution side, so that we can propose that yes, this could be the possible corrective actions. That was the idea for proposing this in the review paper. So what we went on is the possible way, after looking into that, this could be the possible problems in the distribution network. So how we can restore, or how we can redesign so that the system can prevent further damage in the near future for any of these events. For example, what we proposed here is situational awareness based resiliency implementation and planning. Over here, here what we suggested here is, this is one of the distribution network. For example, this is another distribution network connected through a tie line, right? So we have proposed a PMU at 2 locations, or micro PMU rather, because it's the micro PMU is the common device, what is suggested in distribution network, but in general we call it as PMU, so it has been shown as PMU over here. So what we suggested is we have the two aspects we have suggested: synchrophasor based resiliency planning and synchrophasor based resiliency estimation. So what in planning, what we tried to do is we tried to gather the historical data as we have suggested in this particular work. Right. So based upon this historical data, we have created a database. Yes, this could be the possible disturbances and possible leading to possible outages, consequences. So we have created a database, and from the PMUs, we have tried to take the actual data or real-time monitoring for that particular location. And we have tried to merge both the data set, the historical data as well as the real-time data. And we have tried to see that if natural disaster is happening, intentional attacks are happening, or sudden extensive failures are happening within the system, how the system should respond. That was the idea. So basically, it was a clubbing of two data set. One is historical data set, which we have gathered from the last past 10-20 years data collected, and the present data from the PMUs, so that we can monitor, as well as we every time we learn what changes to be done so that the system does not fail in the adverse scenarios. So keeping this in mind, this is a location-oriented resiliency framework. So the same 33 bus network, we have not changed. The only thing what we did is, instead of putting DGs at all locations, we have specified three DGs based upon certain conditions of optimality. So I'm not discussing those conditions as of now. And here what we did is we have superimposed that at the 5 cyclone prone region throughout the world. So 5 cyclone prone region, one is Southwest Indian Ocean cyclone region, next is Atlantic cyclonic region, Pacific hurricane region, Australian cyclone region, and North Indian cyclone region. And 20 years data set was collected, and the possible pattern of the cyclone were analyzed. So after analyzing the possible pattern, it was divided into a this particular 33 bus network on the map was superimposed by a mesh grid structure. Mesh grid structure, if you see cell 11, cell 12, cell 13, it is signifying a smaller region, a smaller square kilometer of the area, so that specifically we can understand how this area is affected, or particular this area is affected, because this particular area will cover maybe 2 lines, right, along with maybe 1 or 2 loads. And we have tried to analyze the pattern of the wind. You see, this is one pattern shown of the cyclone. This is another pattern of cyclone. This is another pattern of cyclone. So based upon the data set, we have tried to superimpose these things and try to test how the network is behaving. So based upon the geographical location, the sample number of samples per year are collected, and average wind speed of the cyclone, the different trajectories and the radius has been shown, the minimum trajectory, the intermediate trajectory, and maximum trajectory, to understand the line-wise disruption that is happening within the system of this particular network. After analyzing it, we found that that only if we analyze with only micro PMU and only unmanned aerial vehicle, two things: unmanned, we definitely didn't have any kind of unmanned aerial vehicle, but we tried to do the mathematical modeling for same to understand what is the stress of the poles at that particular region, and tried to observe that from the micro PMU was majorly giving us the voltage data, current data, and power data, and the stresses were analyzed using this mathematical modeling of unmanned aerial vehicle. And we have given certain observations, that which are the potentially safe region, network resilient parameters, potentially unsafe region. So all these possible observations were attained based upon the minimum trajectory, maximum trajectory, and intermediate trajectory. And you see the certain highlights are shown, showing the potentially unsafe locations. And you can see over here that this PMU is giving 0 voltage data, means this could be the possible region where the cyclone might have struck and damaged, and the possible stresses were analyzed correspondingly. So potential unsafe regions were analyzed. After that, for different trajectories, the combination of micro PMU and UAV simultaneously for different trajectory for different regions were analyzed, and we have proposed that this could be the possible candidate locations for high risk, all highlighted in yellow color. You see, the J and K are signifying the lines within the specific bus. These are the bus numbers 1 and 2, 2 and 3, and accordingly these are the bus numbers. And we have, based upon the minimum, intermediate, and maximum, the node rankings were done, and accordingly the potential, the high risk region were analyzed. Were obtained based upon the cyclone trajectory. And then we found that without any mitigation technique, when we analyzed through the resiliency trapezoid, initially, if now, one thing I forgot to mention, since reliability and resiliency are probabilistic in nature, so its maximum value considered will be 1 and minimum will be 0, or intermediate value between 1 and 0, right? So if you see the normal condition, it is shown as 1. Whereas when a cyclone has struck that particular region and has damaged, the probability went to point, or the resiliency went to 0.344, and the sustenance of degradation was this particular region, TNDG1 to TNDG2, after which is repaired and restored. But even after restoration, the reliability or resiliency achieved was 0.436 only. So that was not satisfactory. So we proposed on reconfiguring the network. If you remember, at the beginning, we discussed that by reconnecting the tie lines, we can reconfigure the network. So on reconfiguration, it was found that the degradation was 0.75, and restoration, after restoration, it enhanced to 0.753. Then what we suggested is pole reinforcement, means the pole of the distribution network should be reinforced or restructured, so that you can the pole damage does not happen after the stress test. And we found that after restoration, it was 0.894, and gradually it sloped up to around 1. This was a good achievement, and the damage was also not that much. The damage was 0.736 only. And another aspect, what we did was we splitted the network. The 33 bus network was split into multiple small networks, and there it was found that the damage was 0.655 and restoration was 0.811. But out of these 4 strategical solutions, the solutions which was viable and it gave a best result was pole reinforcement. So in cyclone prone region, if proper stress testing can be done and pole reinforcement can be done, then the results will be good enough to mitigate this kind of problems. So this was the resiliency estimation proposed in our nature portfolio paper. So next, so one aspect what is of concern is, even though we have the distributed generation over here, at cyclonic conditions, obviously the DGs won't function. So the DG generation was not taken into consideration while doing this particular estimation of resiliency. But DG estimation is important under this category of resiliency, which we are calling as non-deterministic resiliency. Non-deterministic means that, for example, the solar is going down. Solar irradiation is going down. For example, it is going down from 1000 watt per meter square to 800 watt per meter square, or maybe 200 watt per meter square suddenly after maybe in the mid noon or something like that. So the possible cause, which is unknown to us, is what we are referring to as non-deterministic resiliency. So the possible cause what we identified could be the air temperature, relative humidity, dew point, which is under the weather factor, the irradiation drop because of shading, shading because of some allied shading of structure, or maybe cloud pattern, moving cloud, soiling. After the solar panel is exposed for a longer duration of time, soiling is a very common phenomena. Then panel temperature, some abnormality in panel temperature may lead to irradiation variation. Another aspect is the component part, where aging is one of the major aspect, and malfunctioning obviously is one of the aspect. So this could be the possible reason for source uncertainty, what we are claiming as non-deterministic resiliency for solar PV. And this uncertainty has been tested for different time. You can see minus n at t and t plus n. So with the variation of time, this uncertainty aspect has been taken care, and it has been proposed what is the cause. Air temperature is the cause, RH is the cause, dew point is the cause, soiling is the cause. What is the cause for this drop in the irradiation? So if you can see over here, irradiation NDR is shown over here, NDR is shown over here, non-deterministic resiliency not meeting the possible load demand. So here we proposed from this particular model, here the SPV data has been collected for different time of the day, different time of the year, and by using a particular distribution curve, which we are referring to as beta distribution curve, the solar uncertainty at different time of the day and different time of the year has been fitted, and the load pattern for various network peak load and base load has been considered, and both have been hybridized by an approach, proposed approach, a hybrid model, that is MCDM DBN, Monte Carlo decision, sorry, I'm a multi-level, multi-criteria decision-making approach based upon dynamic Bayesian. So they both has been clubbed together, and the corresponding non-deterministic resiliency assessment was done based upon the availability of different components. So this was done by a linguistic variation of irradiation, where the linguistic we have used the fuzzy parameters for for different parameters considered, that is dew point, RH, relative humidity, air temperature, panel temperature, soiling, shading, and based upon the linguistic scale, the ranking has been done what could be the possible reason for this particular source uncertainty. So based upon that, we found that for bus number 12, bus number 24, and bus number 30, the real power output was dropping significantly for specific time, and the load was not being served for a specific duration of time, leading to the non-deterministic resiliency uncertainty. So this was one of the aspect. So the source uncertainty was one of the aspects. Similarly, different other aspects were also taken care as an attribute. That is, communication failure could be the reason, distribution line failure could be the reason, error in status of switching of the devices could be the reason, excessive automation, GUI complexity, control and other algorithm, clock speed, memory size, number of core, historical database, time of recovery action, and future system states. So different attributes have been taken, and finally it has been assessed how the network can be made resilient and what features should be taken care, what should be given more importance. So finally, instead of detailing much into this, I am showing you the result. So source uncertainty is one of the cause, then CAG was one of the cause under this was under perception, this was under comprehension, and under projection, HD was one of the cause for the different scenarios collected. Further, we did what? We did an analysis of this diurnal weather uncertainty for different part of the Indian climate, that is a northern zone, western zone, eastern zone, and southern zone, for different types of SPVs. For different types of SPVs, considering the soiling rate and the shading rate. And we found that the pattern was like this. For bifacial type, for three different types: monocrystalline type, polycrystalline type, and HIT for bifacial type of solar PV. And under monofacial type also, monocrystalline, polycrystalline, and HIT were tested. And the capacity you see over here, the practical capacity, the actual capacity, and percentage loss due to this source uncertainty was evaluated. And it was found that if you go do your analysis without considering the uncertainty, then the losses of shading and soiling were not creating a havoc over here. However, when the source uncertainty were taken care, you see that irradiation loss was around 1.17% and soiling loss factor was 3%. So this was for a specific panel, one particular panel or an array of panel at a specific location. So if you increase the array and go for a wider region and spread out for different part of the country, then this cumulative loss will go up to a high value. So this is one of the present work what we are focusing. We are collecting the image data set for because of this shading loss and soiling loss, and we are trying to analyze what could be the possible mitigation measures by which we can analyze and restore this problem of uncertainty, or if considering this uncertainty, practically how we can go for additional injection without violating the power system parameters. So now with this, I conclude my session of the technical part. Now, as I said, the process of this patenting. So this is one of the, I'll just, how will you convert your findings to patent? I'll just show you. So this is actually one of the format what we follow in our institute. So I would just like to show that. So this is the application form what we follow in our institute, right? So that you can understand those who have done, definitely they have expert, but those who are new to this particular domain of how to apply or how to proceed, because there was a time when even I was struggling how should I proceed, what should I give in my what should be my how should I put up my application so that I can float it for patent. This is regarding a particular format for utility patent for Indian under Indian patent category. So basically, title of invention is needed, followed by details of the inventors. So that is important. Followed by the brief description of the invention. What new process, system, machine components you are proposing. So brief description of the invention is important, and detailed description of the invention will constitute of state of prior art. State of prior art will include the literatures of the academic research as well as the patent search. Both has to be done, and focusing on what is the novelty, what is the gap the existing literatures have, and what novelty the specific inventors are claiming. This is followed by description of the specific work, which will be beneficial in technical and commercial, which will have a technical and commercial merit. Novelty should be always given in point wise. Then inventiveness, what are the novel features, what you are claiming based upon the proposed gap. Then advantages, based upon disadvantages when you are giving, you have to compare with the state of art work, and then you have to give the advantages. And then testing, have you tested it experimentally, then the detailing of that is needed with your proper results. Then funding support, obviously if you have it, you will if you have to give the sponsorer's name and all those details has to be given. Then this is important, information for protection of IPR. Then here you see that date of conception of the invention has to be given with the references and comments. Has the invention been presented at seminar, discussion, and other places, that has to be mentioned. Usually it is recommended that if you have presented this particular idea in some other place, then you will not be able to go for patenting, because self plagiarism is a major aspect in the patent perspective. So you should never go for publication prior to patenting. And please provide the anticipated date of submission of publication or communication if you have published the material. Has the invention been reduced to practice? So all these things has to be given properly, mentioning the proper date. And if you do not have these details, obviously you will go for no. Then commercial potential of this of particular the proposed work. So list of probable users, industrial organization, targeted companies have to be given, mentioning the name. List of probable organization who may be interested in technology transfer, the name of those. Potential marketability has to be given, and prior disclosure and possible intent. That is, has the invention been disclosed to industry representative or are there parties? So, money. If when you are proposing this, you should be care should be taken that, and if you are disclosing it already, that should be mentioned, because somebody can take your work and may float it as their own work. Has any commercial organization shown interest in this invention? Give details. So this is recommended that this should all be not done initially prior to. First, you should get your patent published. Then you should go for any kind of further access to these companies. That is usually recommended. And development stage, whether it is embryonic stage or partially developed or fully developed, you should mention whether accordingly it will be processed actually from the patent office or the attorney who is concerned to help you out in this particular work. And potential for international patenting, so that also you should give it. So this is the application form what we usually follow in our institute, and this is appended by the complete disclosure form with annexure should be submitted. And by annexure we mean that just like we are writing papers, we are writing papers, the same kind of same format you can submit as an annexure, mentioning the details of your complete work, and that is evaluated actually in the by the attorney concerned, and then the concerned person will give you suggestion with by the search done by him, and then he will suggest, yes, this should be the addition you should do. Either he will suggest that you give some additional work, some additional result, or after searching from their end, they will suggest that you see to this particular existing patent and defend, give us the necessary description, and suggest that these are the gaps in the existing work. So these could be the possible suggestions which will be coming up from their side, after which they will give you a set of forms are there, form 1, form 2, different forms are there, which they will be guiding you. And after certain duration of time, it will be if it is found okay, they will be publishing it actually. So this is the basic format, drafting and filing of the complete patent application. And then after that, once the patent is published, some kind of examination is done. First examination report is sent, and you have to defend that particular report, just like we give answers to reviewers comment for different publications. Similar kind, they will be asking certain questions and you have to answer it, after which there will be a hearing. In the hearing, the main inventor or the primary inventor can attend, or all the inventors can jointly attend and defend the hearing, and that will lead to the final decision whether it will be granted or rejected. So this is the actual general process. The timing depends on the majorly on the attorney, but the standard timings has been mentioned as per the available source from the Indian patent process. I have given the source also at the bottom. So this is the process of going for utility patent in India. If you go for design patent, then the design, different views of the designs are expected. The top view, the bottom view, the side view, the angular view, all these views are generally asked by the attorney, followed by what is the novelty in your design. So that is for specifically for design patent. So this is the process which I liked to share, because I think this will be helpful. And thank you. So this is my contact email ID. If anybody further wants to contact me regarding any of the aspects, whether the domain aspects or patent related aspects, I'll be happy to answer to the queries. So thank you from my end. Thank you.
Thank you so much, madam. And now, participants, you can unmute yourself. And if you have any query, you can unmute your mic and ask questions. The floor is now open for any question, answer, discussion you want. Participants, you can unmute your mic and ask any question that you want.
Ma'am,
Yes.
is there any reliability factor, that is resilient factors, we can use
Yes.
so that we can measure and say how far my system is resilient?
You mean the indices you are talking?
Um, Apart from the
What
normal
kind of measure?
reliability indices, is there any way I'll be able to defend my work, stating that during, for example, a cyclone condition has occurred and I'm
Yes.
suggesting some option for it. So how can I say, apart from the reliability factors, how can I say like my system is more resilient?
Yeah. So usually you'll get to see that the reliability factors are only brought into resiliency factors as an index, but consistency index is one of the index what we proposed. How much consistent it is, there's specific calculation to that consistency ratio and consistency index, based upon which you can coin that your system is resiliency or not. That will give you a probabilistic value only, but it'll tell you that your system consistency and in terms of consistency index and consistency ratio, that is one of the index by which you can coin your resiliency. Apart from that, if you go for the resiliency index, if you search in Google, general literature review paper is there where different resiliency indices are suggested. Now that will depend on type of work. Just like cyclone you have said, in the cyclone case what we did over here is, based upon the resiliency trapezoid, we have seen the consistency, and we have suggested the possible mitigation measures is enhancing the probability from the degradation phase to the pre-disturbed phase. That is what we have done in our work. But mostly you will get to see that reliability parameters are only proposed as resiliency parameters as per the uh, interest of use.
Thank you, ma'am.
Okay. Any other questions?
Participants, you can unmute your mic and ask your questions. Or alternatively, you can also contact madam on the provided email ID.
I'll put my email ID in the chat also. I think only meeting members have access to chat. That is
Madam,
what is written. You can provide on my behalf. If any query is there, I'll be happy to answer even later. So I hope if any other questions are there, I'll happy to answer.
Good evening, ma'am.
Yes.
Ma'am, my question is, ma'am, what is the significance after reconfiguration of 33 bus system? What is the changes you in your result? What are the changes in?
Yeah, I'll just go back. I need to again reshare my slide. Otherwise, I think I'll just go back to my slide. Is my slide visible, Nitish? I think it is Nitish, right?
Yes, ma'am.
Yeah. So my slides are visible, right, to you?
Yes, ma'am.
Okay. I'll just show what I'll try to answer you. If you see over here, you can see the voltage profile and the bus numbers, right? Bus number 2, bus number 1 has been omitted because it's a utility connection, 2 to 33, right? Just a minute. Yes. I am in bus number, I am in slide number 11. Is it visible? Slide number
Yes,
11?
ma'am.
Yes, ma'am, it
Yes,
is
ma'am.
Yeah.
visible.
So
Yes,
what
ma'am.
I intended, what I intended, this is my reconfigured network, right? What I intended to do, or what is the modification in my output is with 33 bus normal base configuration when we tested with injection at all the nodes. Injection at all the nodes means solar PV at all the nodes. The voltage profile in bus 2 to 7, you see it violated the standard limit of lower limit going below 5%, more than 5%, bus number 2 to 7. But when we reconfigured and did the same experiment, we found that the voltage limit was sustained within the limit of low voltage and high voltage as per IEEE 519 standard. So without considering this voltage limit, you cannot proceed for your experimentation further. You cannot go for injection further. So this reconfiguration helped in injecting at all the nodes without violating the primary condition of voltage limit. Could I answer to the question?
Ma'am, if there is a condition that if some of the buses the solar panel get out, then what will be the impact on this
Solar
voltage
panel
profile?
get out means mane damaged, or it is
Yes, ma'am.
what you intended to
Means get faulty for some time,
faulty?
then
Yeah,
voltage
yeah.
profile is down at that
Nah,
bus.
yes. Yes, voltage profile down at that particular phase. Voltage profile actually, when you are testing, let us say bus number, that also depends where your injection is, right? So let us say bus number 23, 24, 25, or bus number 2, there the system is faulty. I mean the solar PV is faulty. The first thing will be the breaker at that particular location will take care. First thing. Second thing is, since it is connected to the utility, if the power sharing which was done by the SPV will be by default taken care by the utility. So there will be no problem of the voltage profile being violated at the corresponding buses. Because we are not doing it in an islanded mode, we are doing it in a grid tied mode. Okay. So voltage sustenance will be done by the utility at that time. The momentary dip might occur, but if it is going below the voltage limit particular there, let us say the voltage limit has crossed this particular low voltage limit, or it has gone above the high voltage limit, the corresponding breakers will take care and it will trip that particular feeder to prevent that problem to sustain for low voltage limit or high voltage limit. Over voltage and under voltage relays will be functioning in that case. Could I answer?
Yes, ma'am. Ma'am, but this configuration is this for mm, this configuration is made in the condition when the solar is connected at all the buses.
The
I am right?
configuration, yeah. Now both. Here also we have done. Here
Okay.
also we have done the same. Base also we have done the same. And here also we have done the same. The objective was how much injection we can do. Here, our objective was how much injection we can do in the system without violating the voltage limit, current limit, and the power quality. That was the objective of this particular work.
But ma'am, the injection is at all the buses is equal, I think.
Injection at all the buses are equal. Means I'm not getting your point.
Yes, ma'am,
Your capacity
yes,
you
ma'am,
are talking?
capacity of solar PV is equal at
Mhm.
all the buses. You have
equal rating has been taken. Equal rating has been taken, but the further when we worked into this, when we went for dynamic operational hosting capacity, we limited that to optimal locations. Optimal locations were decided based upon the voltage profile. Means, for example,
work there only also. And
Yeah.
when the PV is installed at some of the locations with some of the unequal capacity, then this configuration will all work
Yes,
at there.
it worked. It worked. It worked at that condition also.
Okay.
It worked at that condition also, but definitely the ratings were different because here in this particular work, what I intended is ki if you go for injection at all the buses with a specific capacity, then the violation is not happening at the individual buses. That was the objective.
Ma'am,
The later
one
objective.
Ma'am, one last question. As you told, the voltage violation is near to this SVS station, means bus number 227. Is there any reason that it is near to this station only?
Near to the station, the reason is since it's a distribution network, we know that in a distribution network is a kind of radial kind of network, right? So in a radial network, as you go away from the source, your voltage drops because you have loads also in between. But near to the source, when it's a radial and you are near to the source, then the voltage profile is near to the normal condition. That is the convention of distribution network. That could be the possible reason.
Sorry, ma'am.
Yeah.
Nitish, actually, we have a crunch of time. I think you can contact Madam later on because we have next session also lined up.
Sure, ma'am. Sure, ma'am. Okay.
Okay. Thank you so much, ma'am, for.
Okay. Thank you.
Ma'am, firstly, ma'am, I have very few words to express my gratitude for your valuable time and invaluable insights. And ma'am, secondly, and more importantly, thank you for graciously accepting our request to deliver the session. On behalf of the FDP Organizing Committee, I sincerely thank you for your valuable time and insightful deliberations, your expert perspectives on patent, then enhancing hosting capacity, operational reliability, resiliency in active distribution systems, along with advanced monitoring, control strategies, renewable integrations significantly enriched the FTP. The session provided meaningful technical insights and also the future research directions that will greatly benefit both academia and industry practitioners. Thank you once again, madam. And madam, with your permission, we would now like to take screenshot along with our participants.
Yeah,
so
sure. Thank you so much.
Request all the participants to please switch on their cameras, and this might take some time, 1 or 2 minutes. Participants, please switch on your cameras. We have few more. I think gradually more participants are turning on their cameras.
Actually, participants are also tired. Saturday, and this is the time.
But we enjoyed your session.
Okay, thank you.
Thank you, participants. Now you can switch off your cameras.
Thank you, ma'am.
Thank you. Shall I leave?
Yes, ma'am. Thank you so much, ma'am.
Thank you, ma'am.
Thank you.
Very
Thank
good
you so much.
Thank you, ma'am. Thank you so much, ma'am.
Thank you very much.
Thank you. Thank you.
Thank you, ma'am.
Best wishes.
Thank you, ma'am.
And I think the next participant, the next expert for today's session, Mr. Utpal Kumar Sarkar, has already joined. Utpal sir, are you there in the session?
Yes, ma'am.
Good evening, sir.
Good evening, ma'am.
So we will wait for your formal introduction. Deep sir.
Hello, am I audible now?
Yes, sir, you're audible, sir.
Yes, sir. Welcome, sir. Could you, sir, please share your slides so that we can check?
Yeah. Are the slides visible?
Yes, sir, it is.
Yes, sir.
On behalf of the organizing committee of this FDP, I extend a heartfelt welcome to our resource person, Mr. Utpal Kumar Sarkar, for delivering his talk. Sir, it is really an honor to have you among us. Utpal Kumar Sarkar, sir, is a senior manager, E&M, and currently serves as the in charge of renewable energy projects in the CCL region. He brings extensive experience in the design and execution of PV solar power plants with multiple projects implemented across the CCL region. Mr. Sarkar holds a BTech honors in electrical and electronics engineering from NIT Jamshedpur and has further strengthened his managerial and strategic expertise through the PGDX program at IIM Mumbai. So I would request Utpal sir to kindly proceed with his session.
Yeah. Good evening, everyone. So I will be focusing
Good evening, sir.
major. Good evening. Yeah. Thank you. So I will be focusing majorly on the issues faced by megawatt scale PV solar power plants and also the related issues faced by the storage systems right now in India. So actually, I was fortunate enough to be among the few people who were selected by the company to this to just lead the renewable energy venture in Coal India. So as a part of RI3 team under the able leadership of our HOD Subodh Kumar sir. So we just entered into this venture of renewable energy way back in 2022. So the first megawatt level power plant which we commissioned was at Giridih. That was 4 megawatt solar power plant at Giridih, and fortunately enough, it is one of the best solar power plants that is working under Coal India with a CUF of nearly 26%. And people who will be knowing the solar technology, a solar power plant, especially in the eastern region, like Giridih, and that giving a CUF of 26%, around 26% on an average. So it was a major achievement on our part. So with that, we also face some of the challenges which I will be discussing, because we are now in a process, because we are mandated by the government of India to install 425 megawatt of solar power plant only in the CCL region itself. So and overall, the target for the renewable energy is around 9 gigawatt for the entire Coal India. So what we faced in few of the tenders, and what we face, the technical issues that are being faced in the plants which are already operational. So I will be discussing major points, technical points also, and also some of the challenges related to the regulatory system and the IR issues that we faced. So first of all, the first slide goes like this, that First of all, what we are facing right now, because when we are floating the tenders, we are very stringent with our specifications, and we are following the international standards related to the solar modules. But still, what we are facing right now, especially with some of the plants which are installed over the overburden dumps, people related to mining, or maybe living near the mining area, maybe knowing that for extracting coal we have to first extract the overburden, and then we expose the coal seam, and then mining is done. So these overburden dumps are being utilized, and it has been mandated by the government also to repurpose these overburden dumps to solar power plants. So in one of our solar power plants, which was overburden dump, we faced few of the problems like LID, LETID, and PID. So LID is light induced degradation, because it was a 90-meter, it was at the height of 90-meter from the ground. And also due to in overburden dumps, we have shelly coal also. So they also provide the ground, they also make the ground temperature a bit higher than the ambient temperature, nearly 2 to 3 degree higher. So what we faced in that particular solar power plant, that we the light induced temperature degradation also we have faced, and potentially induced degradation. Actually, what we have faced, that PID, as the temperature increases, this PID uh, and LID both increases. The both increases with the increase of temperature, and this has been found in many of our panels, and we have to just replace many of the solar panels within an year. Like we have to replace around 10 to 20 solar panels, and that too only due to this LID and PID problems, because we all know that in a string, if one or two PV modules do not function properly, or do not provide the voltage and the current which they were supposed to, the entire string suffers. So these are the issues which we are facing. And also because these solar panels are being manufactured by the players who are very new in this field. So, and also these the testing condition that has been provided in the international standards, those are either European standards, and those are not being tested in Indian conditions. So specifically, I request the academia on your part, so if you can provide some solutions regarding this LID and PID problems, because we have commissioned that plant, and it has only been a year, and we are facing these issues. So, and again, there is hotspot formation also, and these are occurring due to cell mismatches, because we all know that in India, we do not manufacture the cells, and only few 8 to 10 potential parties are there who are now being introduced in ALM2 list, ALMM2 list by the MNRE. So only few cell manufacturers are there. So actually, during when this tender was floated, actually we only mandated ALMM1 list only. So in that case, cells were directly imported from China, and that has been provided in our panels. So there is a high probability, because even if there is a contamination, or there any of the quality control measures are skipped in the production process, there is a cell mismatch, and this results in hotspot formation. Okay, this problem was not so relevant to our part, but in some of the cases, means in other subsidiaries, especially one of our solar power plants which is being installed in Khavda, Gujarat, those are harsh condition provided by saline air and saline water in the Bhuj region. We face a lot of problem regarding that. So in that case, I would recommend that if this hotspot formation being faced in some of our solar plants, power plants, what are the important solutions that can be provided? And soiling losses, and I have already asked one of the professors of BRT only, Sonal ma'am, regarding this soiling losses. I have asked that if some solutions can be given, because all our solar power plants are being installed in areas which are near the coal mines. So we do face this soiling losses, and in our design only we are using 10% as the soiling losses and then designing our solar power plant. So uh, these 10% is quite higher, and even we get complaints from our bidders also that this 10% is quite higher. But we do recommend that in case of solar power plants, what we have faced, especially in rooftop solar power plants, this 10%, even if this 10% is not been kept in the design consideration, then we will be significantly losing uh, in terms of the actual solar capacity that is provided by the bidder, because they will provide less DC capacity and less AC capacity to account for this soiling losses. So in all our tenders, what we are doing, we are keeping 8 to 10% as the soiling losses. And thermal stress, we all know that hotspot and everything, temperature, especially in some of our solar power plants which are being installed over overburdens, thermal stresses are being faced, and especially the glasses are cracking, either due to thermal stresses or what we have felt due to vibrations, due to vibrations in the zones for the blastings that are being done in the coal mining area. So thermal stresses, few PV modules have also the glass over the PV module have also cracked, and either this has been as we have contacted the OEMs, so these thermal stresses are being faced also. So, and also we have found this inadequate quality control in one of our projects, and one of the OEMs who is presently stationed at Durgapur, and they haven't followed inadequate quality control. So we have to just send back. They have sent 1 megawatt of one 40 kilo 400 kilowatt peak of the module in one of the trucks, and due to inadequate quality control measures, we have rejected the entire lot. Means they have transported, and we have transported back to again to the OEMs. So these are the major challenges which we are facing in case of the technical issues that are being faced in the PV module plant. So we all know that all this results in the reduction in capacity utilization, and so if especially this LID and TID problem, what is being what is being promised by the OEMs, these LID and that PID problems are actually what is being faced at site is quite different. There is stark difference what is claimed by the OEMs and what we are facing at the site. So these are the major issues, and we have also talked to NTPC peoples and all other major developers of solar power plant. They are also facing the same issues. So again, this inverter and control system failures, especially with string inverters, central inverters, yeah, they do face some technical issues, but that is that is owed to improper installations. But in case of string inverters, we are facing a lot of issues. Especially this year, we have faced incessant rains in some of our solar power plants. So there was high failures of string inverters. The IP rating, what was promised and what was provided at the site, even we all allowed only IP54 rating solar string inverters. Still, some of them either faced short circuit issues, or there were some spark issues. So there was a high failure rate, especially with the string inverters. And what is being now promised by the industry, the central inverters are getting obsolete, and all the central inverter manufacturers are complaining that as the government tenders are coming, most of them are preferring string inverters. But I don't know. But what we have faced, as far as reliability is concerned, string inverters were way more less reliable than way less reliable than central inverters, because the Giridi plant, where we are getting a C of 26 percent, so all the inverters there are central inverters. So in that case, it happened that string inverters in one of the solar power plants and central inverters performed quite better. And also there was thermal derating, especially in the month of uh, April or May. There was thermal derating, and due to this thermal derating, there was tripping happening in some of the inverters. So what we have done, we have asked the bidder that increase the overload current, so that this thermal tripping due to this thermal derating doesn't happen. Actually, it was a temporary solutions because we all know that uh, in case of inverters also the overloading what we have allowed is nearly 10 to 15%. But in some cases, even at when the relay setting was done at 110%, still it was tripping, and that was during the summer months only. So this thermal derating was happening, and although we have planned all the inverters with ambient temperature of 50 degree. So actually in Indian conditions, these equipments are not performing as being said by the OEMs. And also grid synchronization, it is one of the major issues with all solar power plants, especially because land is available in the rural areas but grid is not available in the rural areas. Especially in the state of Jharkhand, CTUs are situated mainly near the big cities only. What we are facing right now is the Giridi mega project what we are planning, 150 megawatt solar power plant along with a battery energy storage system. That project is delayed by 1 year due to non-availability of the grid there, because DVC has a substation there, but 220 kV bay is not free, and they are again constructing another 220 kV substation. And when that substation will be constructed, then we will get a grid connectivity. So this grid synchronization is a major issue, especially in the state of Jharkhand. And software issues are there because SCADA and everything, and this solar power plant thing is quite new, especially in coal India. So what we are facing right now, that even it's mentioned in the tenders, we have to push a lot because the standard softwares that are available in the market, they are quite simple, and what they are doing, they are not providing analytics, they are not providing the failure timings, the failure frequency, and for that, it is a great problem which we are facing. We have to do we are in some of the projects. The first project that we have executed at Giridi, we have just taken the specification given in the SECI tender. So in those tenders, the software or the SCADA system that has been that were provided, that were quite simple. So this analytics and those parts were not included. So what we have to do is we have to do back calculation, manual calculation in Excel to get the results that are to get the desired results. So this software issue that has been standardized in the Indian conditions, Indian market, I think that also needs to be looked after. And this power quality issue, we all know that in case even if there is a 3% higher harmonics being injected into the system, either into the grid which the solar power plant is connected to, or the solar power plant itself. We have faced frequent trippings, especially in case of Giridi. And this total harmonic distortion allowed is up to 3% only. So anything more than 3% in the grid, even for a intermittent period, we are facing trips. And from each tripping creates an energy or the power loss of around 15 to 20 minutes to again restart the inverter. The inverter synchronizes with the grid, means from every tripping to again the power being injected into the grid, there is a delay of around 20 to 25 minutes, and those are valuable 20 25 minutes because those were peak solar hours. So we have lost a lot in case of Giridi and also in case of Balakudra. Again, this transformer and BOS equipment problems. Inverter duty transformers in India were available way from 20 to 25 years back. But the testing or the harmonic currents that are being injected due to the solar power plants, the string inverters, and all those electronic devices connected to the solar power plants, those string inverter duty transformers are not able to handle, especially of the manufacturers who are new in this field. Being a public sector, we cannot make our specifications so stringent that only few players or few major players can participate. So this is one of the limitations of the government tenders. And IDT, though lot of people get type test reports from CRC and everything. So, uh, type test report from the uh, uh, government laboratories. Still, these inverter duty transformers are facing issues in the actual conditions, especially due to overheating when there is high harmonic injections or during high temperatures. So these inverter duty transformers are either being tripped, or in some cases in one of our solar power plant, not in the CCL region, but in one of our solar power plants which is situated in Maharashtra, we the IDT field within I think 7 to 8 months of installation, and that IDT was around 10 megawatt. So these are major issues, this vector group mismatch, because there is a lot of confusion in this with the OEMs also. So we are uh, asking all the inverter duty manufacturers that please give us this YDD connections, not DYY connections, because YDD by its inherent design uh, just tries to minimize the harmonics in the LV side only. So this vector group mismatch issues are also being unknown to the OEMs. So many of the solar power plants in India are still running on uh, DYN, YDD forms only, of vector group only. So that leads to higher harmonic injection in the system, and that leads to tripping, frequent trippings. And also cable system failure rates are also high, because most of the solar power plants, especially in Gujarat, are facing a lot of UV radiation damage and joint overheating, aluminum conductor creep, everything
ଡିକ୍ଲାରେସନ
is
ଦିଅନ୍ତି ଖାଲି ସେ ଡିକ୍ଲାରେସନ ଦେବେ ଖୋଜୁଛୁ କଣଟା
And this switchgear nuisance stripping I have already discussed, and earthing system deterioration, especially due to non-availability of proper IS, especially in the DC side earthing. So we are facing issues regarding this earthing issues also. So these are the few technical things which we are facing right now. And grid integration challenges, we all know that state utilities which have provided us this uh, even state utilities are asking us to curtail the generation during low periods, and we have done that in case of Giridi also, as asked by DVC. Just as asked by the DVC people at Giridi, we have to at certain times we have to run our solar power plants at a lower capacity, because we were not allowed by the state utilities to inject solar power plant in their system during the low demand hours. So, and reverse power limitations we have already discussed. Low SCR inability, because all the Indian grid is at the time is at the developing stage. We are just, especially the eastern grid, is at the nascent stage of development, and few private players are now coming, Adani and everything, Adani transmission are all coming. So I think within 5 to 7 years down the line, we will have a very robust eastern grid, and then we will be facing less issues regarding this, especially with the connectivity issues that are being faced by solar power plants. And also grid compliance code are very stringent in India, and some of the clause written are like, none of the solar power developers will ever try to even take a little bit of risk, because the onus lies not only with the solar power developer, but also with the concerned person who have given the request for this connectivity, and who has there is an and who has signed the PPA or this grid connectivity agreement with the uh, 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 state utilities. That person directly is liable for all types of damages that are being that will be done due to solar power injection. So it's quite stringent, and it's quite restrictive. And even sometimes it happens that due to technical errors that are what we have already discussed, this harmonic power injection was on the side of the DVC, but still we have got strict letters from DVC regarding that our solar power plant was injecting harmonics more than 3%, and we were warned that if these things happens again, they will just withdraw this connectivity clearances. So these things are happening in India, and especially in the eastern grids. So these are already issues that we have raised with the ministry also. We have written letters to the DVC headquarters also, and I think proper response or the proper actions will be taken so that these things are being taken care of. So grid integration challenge is mainly happening in India. As you can see the table, that the renewable energy have grown in India with a CAGR of 15.72. I think it's we are only second to China as far as this solar energy or this renewable energy growth is concerned. Especially in the last 10 years, the government is very aggressive. We are being uh, reprimanded by the government for just not meeting the targets. We have to attend ministerial meetings every 15 days. So the monitoring is very strict and the targets are very stringent. So this type of CAGR is possible right now, that is 15.72. So these are the major issues why this grid integration challenge is happening, because the rate of growth of renewable energy is quite higher than the rate of growth of the grid, especially the eastern grid. The number, especially due to the challenges due to land acquisition, right of way. So the rate at which the grid needs to be growing, actually it's falling quite behind. I think the growth rate what we have found in the internet is around 1 to 2%, and beyond 2020 after COVID, it has grown at around 2 to 3%, especially the eastern grid. So these type of challenges which we are facing right now is the major issues due to which this grid integration problem is happening in case of all types of renewable energy, especially solar, because solar power is intermittent and it's happening at it, and it's so abundantly available right now that I think 10 days back I was just browsing the IEX site, Indian Energy Exchange, and I found that the power was available at a price of as low as 0.97 rupees, 0.97 per unit. So it is quite tough that the solar power plants which will be upcoming and which will be selling their power in the open market, they will be profitable. It's highly doubtable, because the amount of abundant solar power plant available during the solar hours, and there is a lack of storage energy, battery energy storage systems, PSPs in India to store that energy. So the next is this, as we have already discussed, this you are seeing these two figures taken from MNRE site only. The share of renewable energy, what was there in 31st March 2015, and what it is in to 31st March 2025. We can see that now the renewable energy is nearly 46.32%. 46.32% of the entire energy installed capacity of India. So we can see there is a dramatic growth from right from 29.46 to 46.32. And these are the share of the various types of renewable energy. You can see that solar at the time of 2015, it was dominated, grid was dominated by wind power, especially wind power. There is intermittency in wind power also, but still they are available during the peak hours due to this offshore and onshore wind energy. So as the grid, as the solar space is now dominated by solar power plant. Hello, am I audible? Hello.
Yes, sir, audible, audible.
Yes, sir, you are audible.
Audible,
Yeah.
sir? Audible, sir.
So uh, actually now the renewable energy space is dominated by solar with 61.29% of the total renewable energy that is being installed. So the intermittency, what was there in the grid 10 years back, it's quite higher right now. So we all must have seen this graph. This is the typical electrical power demand curve of India. So we can see that there are two peaks. One is a morning peak that is being taken care by solar, and this there is an evening peak. So our major concern right now in Indian power system scenario is to shave this evening peak right now. So again, you can see another syndrome that is being faced by the Indian power system, that is the solar drugs syndrome. What we can see, the due to this distributed energy or this distributed solar power energy, and also the push given by the government schemes, we can see that the demand is decreasing every year. This 2015, 16, 17, 18, and as the so this PM Surya Ghar Yojana and all these schemes will kick in, especially 2028, 2027, in the coming years. So this solar drug syndrome will be more stark, and we all have must have seen the news that even now CEA is asking the thermal power plants to run their plant at a technical minimum of 55%, and also they are now doing some R&D that how this technical minimum of 55% of power plant capacity can be reduced to 40% to accommodate this distributed solar energy that is available during the solar hours to maintain the grid. And also we know that gigawatts and gigawatts of battery energy storage system, pump storage system tenders are being floated by SECI, but we will see again that what are the issues being faced in those storage systems also. So again, this problem is being faced in some of the mine area of Coal India, because in India, the uniform or the flat land terrain is being used for agricultural purposes, and this non-uniform terrain is given to solar power plants. In Australia, we have vast pastures of land where solar power plants can be installed, but in India, land is a great resource, and we have land crunch also, and only those lands are being provided where no other things can be done, or where agriculture is not possible, but the terrain is non-uniform. In Giridih, we have for this 150 megawatt solar power plant, which is in detailed project report stage, there 386 hectares of land was available, but we are only able to put 150 megawatt solar power plant over them due to this non-uniform terrain. This non-uniform terrain to leads to uh, a great difficulty in designing this drainage system, because we all know solar power plants being electrical system, we have to provide proper drainage. So drainage just designing the drainage system, there is a great challenge. Poor internal road issue, because those solar power plants or those terrains are cannot be accessed through vehicles, heavy vehicles. So transportation of equipments, panels becomes a challenge there. And also the security of those solar power plants is a major challenge in these areas. And also due to this non-uniform terrain, creating a boundary wall is also a great challenge there. And land encroachment and risk and adjacent by from the adjacent communities. We all know that all infrastructure projects, especially in the state of Jharkhand, face these type of issues. So, and O&M challenges is also there because it's quite difficult. We do not have proper research papers available in the academia regarding the failure rates of all the equipments in the solar power plant. So I would request if some research can be done in these fields with proper data from different solar power plants, which are, because solar market right now in India is quite large. We have already seen in the previous graph also. So if it's possible, some academic research can be done in this field so that a proper estimate for O&M operation and maintenance can be just drawn from those research papers. We have some references from NREL USA, but I don't think those things work in Indian conditions. So in Indian conditions, we need a lot of research that what is the failure rates of PV module, what are the failure rates of inverters, string inverters, what are the failure rates of the relays, IETs, everything. So if this type of research can be done by the academia, it will be a great help to the industry so that we can have a proper estimation of the O&M prices. Vegetation control, some issues are there, but it has been uh, uh, in Indian conditions, we do face this type of vegetation control, but right now with the help of environment department, we're able to just avoid this weed growth, able to control this weed growth and everything. And thermal inspection gaps, all megawatt solar power plants in India, they most of them they do not undergo thermal inspection gaps, and that leads to improper O&M and improper maintenance. And so these type of thermal inspection can be done using drones. So these technology are coming up in India, but not at a large scale. But I think in the coming years, this thermal inspection will be mandated by the government. Cleaning efficiencies, robotic cleaning. There was a lot of hue and cry around robotic cleaning. There was a lot of misconception that robotic cleaning is the answer to the megawatt solar power plants. But in Indian condition, what we have found, until and unless we the OEM itself, the original equipment manufacturer itself is the PV module manufacturer also. So in those cases, only this robotic cleaning was successful. Other than that, robotic cleaning, I don't think in India, most of the solar power plants, only few of them are running successfully using robotic cleaning. Manual cleaning, because of the low manpower cost in India, it leads to better cleaning efficiencies in case of without robotic cleaning. And skill shortage, we all know that lot of designing and simulation skills are already available in the market. The issue is especially with proper trained manpower for properly installing those solar power plants, because if installations are not done properly, if connections are not done properly, a single PV module, a single string can damage the entire inverter generation or the entire string generation. So these type of skill high skill laborers are very much short in Indian market. So these are the major issues related to O&M, environment and climate change, and financial and contractual supply and supply chain issues. So module prices are fluctuating significantly due to global silicon supply. In India, though we have come up with ALMM1 and ALMM2 list, means approved list of module manufacturers and approved list of module manufacturer, list 2. These are specially list 2 especially for the cell manufacturers only. But still, we do not have capacities to manufacture solar silicon wafers in India. And due to that, there is significant challenges are being faced, because I know we all know that the geopolitical scenario right now is very difficult. Which country will just come up with new type of tariffs against which country? It's very difficult to determine. Even last 2 days back, Mexico slapped at least 50% tariff on India. So if these silicon wafers and everything, these local supply chains are being not if they are not developed in India, so it will be a great problem if some issues crops in with China and everything, because our major supplier for these silicon wafers is China only. Those cells are now being mandated by government to be manufactured in India. And also there are issues related to inverters. Very few inverter manufacturers are there in India, and even if they are manufacturing, they are not manufacturing, they are only assembling. So these are major issues in the supply chain, especially with the renewable energy. We have gone aggressively, but we are facing shortages for inverters. We are facing shortages for IDTs. In one of our project, the waiting time, the lead time for this inverter duty transformer was nearly 6 months, and we have approached multiple vendors, 9 to 10 vendors, but all have said that the waiting period, minimum waiting period, will be 4 to 6 months. So we have supply chain issues. We have issues related to the price volatility, especially of silicon wafer, steel prices, especially in the year 2022, steel prices went up like anything. So price volatility is one of the major concern because we do not have the entire end-to-end supply chain in India. So these problems are being one of the major issues, especially for big solar power plants, megawatt solar power plant, means 100 megawatt, 150 megawatt. So we are also being mandated by the government and also our company that a proper risk profiling of each and every equipment must be done in each and every of the detailed project reports. So in this case also we will need help of the academia if some help can be provided to have to just do a proper risk profiling of especially of the PV modules, inverters, IDTs, the three major things. And in case of battery energy storage system, the battery energy storage systems, the best technology, everything. So if proper risk profiling can be done, so that uh, risk-based pricing for coming 5 to 7 years can be drawn for our projects. And revenue pressure is also there. Aggressively bids are being placed. We have also done aggressive bidding in one of our projects in Gujarat. We have tried to get that project because we were thrashed by the government for failing in each and every tender that was being floated by SECI. So we went with a very aggressive bid of 2 rupees 55 paise for a 300 megawatt solar power plant at Khavda, Gujarat. So we got that project, but by God's grace, this interest rate cycle was in the downturn, and we were able to receive a loan of around 80% of the project cost at a very low interest rate of 6.97%. So that project was an exception. Uh, we got a relaxation from the government also that we have to use non-DCR, we can use non-DCR panels. So the panel rate also, what we have taken for this project was around 12 rupees per kilowatt peak. So for that reason, this project became viable. Otherwise, it is very difficult. And all the major SECI tenders of 100 megawatts, 500 megawatts, those all projects are in doldrums. None of the projects have even started. And especially, we all know that this aggressive bidding is being done only to just play with their accounts and play with their books, especially with the listed companies. So these things are happening, and for that, especially the public sector, where there is a lot of liability with the cost estimates, lot of liability, lot of answerability with the estimates which are being prepared. We are failing to get these bids, but we are trying hard. Maybe some government comes up with some stringent norms so that this type of aggressive bidding or the bidding which is not practically possible, even unviable projects, even they are quoting tariffs at a rate where the project becomes unviable. So government may come up with some regulations or like that. So maybe 1 to 2 years down the line, especially with the best tenders, government will definitely will come up with some guidelines to how to bid for these projects. Cybersecurity, SCADA, these things sometimes we have faced, but especially cybersecurity threats we haven't faced, especially in case of our solar power plants. But we all know that a few days back, Coal India, Central Coalfields Limited site we were under the threat. We were attacked by under the attack of cyber attack. So we faced some cyber attacks 6 months back. We have faced some cyber attacks. So these things may happen with solar power plants also. So this is uh, the now I'm coming to the second part of this presentation. So any questions till now to the presentation that is being made? Because now I will be switching over to the solar energy storage systems in India and the challenges that we are facing there. So if you can have some questions from this PV solar part, or I shall.
Participants, you can unmute yourself and you can ask questions.
So I will be moving forward.
Okay, sir.
Yeah. So actually in India, a lot of uh, R&D level of energy storage systems are being tried, like uh, uh, PSPs and BESS are mainly the grid level of energy storage system that are majorly dominating the Indian power systems right now. So right now, the target for 2030 is 500 gigawatt of non-fuel, non-fossil fuel capacity by 2030. So the key technologies which will be these driving us to this target will be the BESS and the pump storage projects. So we have already discussed about the growth of the renewable energies. So now I will be moving ahead. Why energy storage is critical for India? Because we all know intermittency of solar and wind, peak demand management means shift energy from off-peak hours to peak hours, and grid stability. Because even right now, what we are facing, none of the power utilities, especially the discoms like JVBNL and DVC, are allowing us to connect our solar power plant to their grid, and they are not ready to buy a single unit of solar power from us. What they are forcing us, that either you install pump storage plants or battery energy storage system, and we will be uh, just adjusting your power during the peak hours, like in the evening hours, 5:30 in the evening to 11:30 in the evening, so 11:30 at night. So this is the period where uh, connectivity will be provided by the utilities, or right now they are very advanced and they are telling that we will not allow grid connectivity to any of the standalone solar power plants. So this due to this the issue of grid stability. So the current RE capacity 2020 gigawatts, we have already, the total capacity is 2020 gigawatt, and projected requirement will be around 74 gigawatt by 2030. That is 411 gigawatt hour of storage will be requiring. So we all know that there is a lot of tenders are being floated by SECI for firm and dispatchable renewable energy. Pump storage, a lot of tenders are being awarded, nearly 35 gigawatts is has been are either under development stage or they are being awarded. So the leaders in this pump storage venture is Madhya Pradesh, and also we know that one of the pump storage is located very near to our state of Jharkhand, that is Purulia pump storage in the Ayodhya Hill. So it is one of the examples of how a pump storage power plant can run successfully for nearly 2 decades. So I would request, if anyone is interested, we can have a visit to this Purulia pump storage. It's one of the pump storage in the world which is being taken as an example for study by even foreign institutes. The Australian Institute, the Australian Energy Institute have also taken this case, and they have done a case study on this Purulia pump storage, and how this Purulia pump storage and how this Pur- and how this pump storage power plant at Purulia was able to just manage the grid shocks that were there during the COVID period. Like 9 बजे 9 मिनट के लिए बिजली बंद करना है, तो that grid shock of 9 minutes was absorbed, especially the eastern grids, and the northern grid was managed very efficiently by this pump storage power plant at Purulia. So there is a great case study there, and you can search the internet to get that case study. So pump storage will be the dominant technology because the storage that will be provided by pump storage is of long duration, like 6 to 20 hours. Lifespan is quite high, 40 to 65 years, and this lifespan can increase up to 100 years, because we know a lot of hydropower plants are working from last 100 years and they are working properly. And also there is a low density energy storage. There is a cost effectiveness of around 80 to 85%. Round trip efficiency is also available in some cases. I was fortunate enough to visit one of India's recently built pump storage power plant at Pinnapuram, that is 1680 megawatt hour, and for 8 hours, means the battery means the storage will be provided for 8 hours, 1680 into 8 hours. So it is an engineering marvel, and they have done a spectacular job by reducing the construction period from 7 years to just 4 years. So it was a great achievement on their part, and it's one of the largest pump storage power plants now under operations in India, Pinnapuram, in the state of Andhra. No, Telangana. So we can have such examples in Purulia also. Purulia pump storage is also working very efficiently. So some of you who are interested may pay a visit to these places. And so the current status is 6 to 7 gigawatt is operational, and in the pipeline, what I have already said, nearly 78 gigawatt is under planning, and India has a potential of 200 gigawatt around. So what we have a target of around 27 gigawatts by 2031 and 32. So these are all figures taken from this Ministry of Power. And how BESS is different from PSP, because PSP is very site specific and BESS is a modular solution. So we can install BESS anywhere where it is required to store the energy. But the major issue, what we have already said, is the technology, which is now being dominated by China. Supply, especially the cells, the cells of the battery, all are being imported from China. So